Ladies and gentlemen, please welcome to the stage President, CEO of the National Center for Simulation, George Chetos.
Thank you, everybody, and good morning. Please rise for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice. Please be seated. Well, good morning. I hope you all made it here with relative ease. I understand there were some parking challenges, but we're glad you're here. We have a great program ahead for you today. I can't wait to see what happens as we go forward, but what I would like to do right now is thank our sponsors. You'll see the list for them behind me in a few minutes. They have been very generous. It's probably the most sponsors we've ever had. And a special thanks to Duke Energy for being our presenting sponsor. At this time, we would normally hear from Mayor Jerry Demings, our co-host in this event. He is traveling, but he has sent a video recorded message. So, Mayor Demings, over to you.
Good morning. I'm Orange County Mayor Jerry Demings. It is my pleasure to welcome you to the 2023 Florida Simulation Summit. This year's summit is focused on digital transformation and the airport of the future. Thank you to the many experts, innovators, and enthusiasts gathered to share your knowledge and ideas on this exciting topic of digital transformation. I also want to thank our sponsors, the National Center for Simulation and Duke Energy, our host sponsor. We are truly grateful for your contributions. As many of you know, digital transformation is happening at a rapid pace. In fact, some companies are going from the Flintstones to the Jetsons in less than a year. Whether you're in cybersecurity, energy, gaming, healthcare, space, transportation, or in the modeling, simulation, and training industry, no one will be spared from the acceleration of digitization. This also includes airports, which play a vital role in the global transportation, connecting people and businesses across the world. Orange County and the Central Florida region are proud to be home to the 6th largest research park in the nation and one of the most prominent modeling, simulation, and training hubs globally. Orange County is also home to one of the busiest airports in the nation. The airport industry is constantly evolving to meet the changing needs of passengers and airlines while keeping up with the latest trends. The concept of the digital twin has revolutionized how we design, operate, and maintain airports, offering unparalleled insights into the inner workings of these complex systems. As we look ahead toward developing an Aerotropolis-style development around our airport, we can look forward to creating that seamless connection between air, road, and rail transportation, with the airport acting as the hub for all forms of transportation. Today, we are thrilled to have some of the most influential voices in the industry. They will share their expertise and insights on digital twin technology and how it can revolutionize the airport industry. In addition, you will hear one of the key elements of digital transformation, which is leveraging data. In today's business landscape, data has become the cornerstone of success. Once again, welcome to the 8th Annual Florida Simulation Summit. Let's continue to work together to engage in meaningful conversations and exchange ideas that enhance our community and build the airport of the future.
Ladies and gentlemen, please welcome to the stage Florida Simulation Summit Chair, Beverly C.
Well, good morning, and it's so great to see all of you here at this 8th summit for the Florida Simulation Summit. This summit began in 2015 to help raise awareness of all the technology in modeling and simulation that this community has been using, starting with all the work that we do in the Defense Department and bringing that technology to all of these different domains. Through the years, we've focused on simulation in healthcare, sports, virtual augmented reality, and transportation and the automotive industry, to using a digital twin model in cybersecurity. This has been great for me. I now work for the Department of Defense, the National Security Innovation Network, where we bring non-traditional problem solvers in academia and in industry, particularly early-stage ventures, to solve problems for our military partners. This area, modeling and simulation, as you will learn from our keynote, Will Roper, is all about modeling and simulation's role in digital transformation. And we have everything here in the community in Central Florida. So we'll be lucky to hear from several fields, including keynotes this morning and this afternoon, 2 panels, and then finally a tour of the Orlando Brightline train station. So to kick off this morning, it's my pleasure to introduce you to the Honorable Dr. Will Roper. He's the founder and CEO of Astari, a member of the Pentagon's Defense Innovation Board, and former Assistant Secretary of the U.S. Air Force and Space Force. Will founded Astari Digital to help make digital engineering's easy button, and today he'll spend time with us talking about the future of digital engineering. Thank you very much, Will. You have a great way of making us all comfortable, and I'm very much looking forward to hearing your keynote speech.
Good morning, everyone. Can everyone hear me okay? All right, well, it's great to lead off because I know you've just had your coffee, and so I get the benefit of riding your caffeine buzz this morning, but I hope you don't need it. This is one of the most exciting topics that very few people writ large understand. And I know I'm speaking to experts this morning, but I hope I'll share something that makes you even more excited to be in the field of modeling and simulation, why I think this is going to be one of the biggest industries that touches every other one. You probably already can guess why. I want to thank Bev for the introduction. I have so enjoyed getting to work with her and know her better as a driving force in this industry. And I also want to thank Alethea Duhan, who's joining me from my team today. She was a rock star for us in the Air Force and signed up for round 2 in our startup, Astari. And I'm going to explain to you why we are trying to make an easy button in this field of digital transformation. But to understand what I'm going to tell you, you really have to understand my journey in digital transformation or digital engineering or whatever we end up calling this. So I started my career working for former Secretary of Defense Ash Carter, who I just had a tribute event in Washington yesterday that I spoke at. He brought me into defense at a time that we were still fighting counter-extremists, and that mission wasn't going to go away. But over a decade ago, he foresaw that there was going to be a rise of great power competition, especially China, and the U.S. military needed to start building complicated weapons systems again, and that the process that it was using had become too bureaucratic and sclerotic. And so he pulled me in to build advanced prototypes. And I had one of those jobs that I couldn't tell anyone about, and my family didn't know where I worked, and it was interesting. Dinner table conversations were a little vacuous on work topics. But I cut my teeth building advanced systems for Ash, and the cornerstone for me for 6 years of my life was aggressively using models and simulations to de-risk. Models and simulations were a means for me to start learning things and identifying risk so that I didn't have to go out and encountered them in the real world, where they're much more expensive to deal with and slower and all those things. It was a way of learning faster. And the lesson that I took away from that time of my career was that models and simulations need to be a bedrock of de-risking programs. And then when you go build something and test, you're doing it because there's something that you'll learn from that test that you wouldn't learn otherwise. And we built a lot of really complicated weapon systems, very few that I can talk about, but like some of the first swarming or collaborative drones for the Pentagon were things that we built. Well, that's a complicated thing to build. Drones that get kicked out of a fighter jet, that have to wake up as they're free falling, discover how to fly, discover each other, and then go out and do some collaborative mission looking a little bit like Hitchcock's The Birds in real life. Awesome but fearsome. Well, that's complicated. So why would you want to have the real world to be the only way that you learn about it? So of course, it's not. You can model that fighter jet. You can model the drone. You can model the aerodynamics of falling. You can model the radios. You can model the software. You can model a lot of it to learn. But never during that arc of my career did I think I would be able to skip the steps of doing the physical test, the physical prototyping, the physical dropping, the physical data collection. Never occurred to me that I would be able to skip that one day. I very much thought of modeling and simulation as a springboard to get me to those tests faster. It was an accelerant. And then, after doing that job for Ash Carter for 6 years, I got asked to run the technology company that is the United States Air Force and later Space Force. So running their technology, their procurement, their logistics, their sustainment, so the business side of the force. And that's a much bigger thing, right? Lots and lots of different programs. And I took modeling and simulation in as my guiding star. We were going to prototype more aggressively. We were going to learn faster, fail faster, and probably save money in the doing, but still thinking in my brain that we would have to go physically test and physically prototyping. So for me at that phase of my career, if you had come in and told me, hey, Will, there's this thing called digital transformation and it's going to revolutionize industry, I would have probably told you, let me see if I can get I would have probably told you, hey, we already do digital transformation, right? We do computer-aided design for everything in the Air Force. We simulate everything. We model as much as we can. We are digitally transformed. And I would probably tell you this isn't a new idea. The whole idea of using computers, of creating them, originally was applied to engineering, doing ballistics calculations for the Army. Computer-aided design's been around since the 60s. Model-based system engineering has been around since the 90s. So what's new? Well, it helps, now that I know what digital transformation is, to set the stage by saying, this isn't a new idea. We've been pursuing this ever since we started making things. It's a fascinating documentary I just watched on building castles, and a lot of it focused on how the master builder had a model of the castle that was used to figure out how to move stones and how to set things like corners. They were de-risking it in a small scale before they had to do it in the big scale. This goes back as old as building things goes. So it's not a new idea, but what has changed, what is different, what I know now, is that how well we can do this has changed. And it's been driven by your industry. It's been driven by many companies in this room and innovators in this field of modeling and simulation. It is going from relative obscurity, I will say, a topic that would not reach a C-suite meeting, to the future where every C-suite meeting will be based on this industry, this topic. So how well is changing? And what I discovered in the Air Force, what changed my mind, was getting connected to Formula One racing. I was not a deep Formula One racing fan, so I got connected to a team in the UK, McLaren, and they were kind enough to kind of let me under the hood, pun intended, I guess, and show me how they engineered race cars. And it was like walking into a science fiction movie. It was amazing. They were building over 1,000 digital twins for every race. And they didn't talk about them the way that I talked about modeling and simulation for aerospace. They weren't representations, they weren't de-risking steps, they weren't learning tools, they were the race car, period. The whole ethos of the organization had flipped from going towards the physical to going towards the digital. Now, of course, they still have to race. That didn't go away, but those cars were real. They made trades on them, treating the results as what would happen on race day, and they had the data to back it up. Their drivers were training on them. So they were able to do a level of design that was just seemed impossible in aerospace. And when they did decide which one of those 1,000 cars was the right one to win the race, and they built it, they would heavily, heavily instrument it so that they could get back over 100 gigabytes of data from the race, not necessarily to just help on that race day, but to help future cars, to improve the environment that was used to birth those digital twins in the first place, and they put that to work too. The race cars continue to evolve. You cannot win Formula One with a race car anymore, period. You win with the best race car building process. The cars must evolve. And for McLaren, over the course of a racing season, they would see about 85% evolution. So imagine if you could somehow subtract the two, and the only things that were common were 15% of the car. Right? It's not even the same anymore. And the results prove that out too. The first car wouldn't qualify for the last race. It's already obsolete in one racing season. And when I saw what McLaren was doing, it clicked for me in a way that has never unclicked, that has never given me a day where I have not been as excited about this topic as I am today, as I realized they have made hardware into software. And they are applying the same agile methodology that allows software companies to go eat the world, to just keep improving their products, keep iterating, keep improving, staying ahead of their competition and keeping up with our demands. They're doing that for hardware, and it was clear how powerful a shift that was that's created the information age and its latest instantiation, the Internet of Things. Powerful pivot, and now it's possible for hardware. Well, how? Okay, that's great. You know, you get intrigued, and you're like, oh, I want to go figure out how to apply this in aerospace. But how did they do it? And that was the second part of my journey in Formula One. It's great, I want to do this. Now I need to understand how you did it. And what Formula One has done as an industry, as a whole, is they have embraced digitization as the way to win, as a necessary means to win, understanding that it's not magic either. I used to describe digital transformation when done right as magic. It looks like a magic show, but it's highly technical under the hood. And so what did they do? Well, they took every model and simulation that they used, like I did in aerospace, as a design tool, as a learning curve, scaling help aid. And they started asking, how much data would we need to treat the output of this model and simulation as reality? And in many cases, the models weren't sufficient, right? Not just because you have a model doesn't mean you're going to put your life on the line. But when the industry was put under cost caps that highly penalized building physical prototyping, physical testing, there was a strong, strong incentive to digitize, to go on the campaign of collecting data, improving models so that reality and the modeling and simulations got closer and closer together until eventually they overlapped and they could pivot from one to the other. I consult on this a lot, and I'll hit that in a second. So I help a lot of companies on this idea of digital transformation and exactly how to do it. And there's always a moment on the team where someone says, hey, Will, let me shut the door. Come on, right? This digital transformation data isn't real, right? We have a product. We need real results. And then I'll usually flip it back around and say, well, let's think about what real is. So, you know, I made airplanes once upon a time for the military. So what was real for me at that point? Well, I would build a physical prototype, usually more than one. Now, they weren't the same, right? You can't make things completely identical. So you get some random and systematic errors between your physical prototypes, and then you take them out to a test range. And the conditions are not exactly the same test to test, right? Air conditions change, wind changes. And even the measurement, like you're measuring with a radar or an infrared sensor, right? Your measurement devices also have random and systematic error. And so what we're doing with real results are really turning the universe into a computer that produces data with error that we manage. Good engineering is understanding and being able to measure and know the distribution of all of those error terms, convolve them all together so that when you've finished the physical prototyping step, you can say, here is the performance that was achieved plus or minus this variance. And if you don't know plus or minus, then you're not ready to go take it into the physical world. Most of engineering, of reliability in engineering, comes from those error distributions and managing them. And the tighter you want them to be, the more it typically costs you to do it. And for a complicated weapon system, you may have 10,000 of those different distributions that you have to manage, and good engineering has been able to do that. But at its heart, real data is just a result with an error statistic that we understand and can manage. And if you think about it that way, it's not hard to pivot, at least not in my mind, to pivot from physical data to digital data, because digital data, rather than turning the universe into a computer, we take data out of the universe and we use it to create a computer of the universe that produces data with error statistics that we can know and manage. Doesn't mean that there are not risks in doing this. There are. And you see in Formula One that just because your digital twin came out of your model and simulation, there are teams that still get it wrong. So it doesn't magically make mistakes go away. It creates a different kind of mistake. But what I'm watching industries do now is when faced with making old school mistakes that are based on physical world innovation versus new school mistakes that happen because of digital innovation, mistakes are mistakes. You go with the digital ones because they're faster in the detection and faster in the fixing. And so when I explain that to industries, it's a little easier for them to understand that a lot of what makes us comfortable about having real results is that there's a human factor to them. Feels good to go watch an airplane fly. Feels good to be able to put your hand on something that was built. But in the end, the thing that's produced at scale is just a result with an error statistic that we manage. And if you can pivot from a physically produced result to a digitally produced one, great, you're done. Go use that model and you're freed from the physical world. That was such a powerful pivot for me. And I knew we could do it. I knew that we could do it in aerospace because a race car is not that much different than a Formula One car. Formula One cars are 60% aerodynamics. So it's like a plane going down the runway, right? It's just about to take off, except it tried to do the other thing, stick to the ground. And the sport's likely going to become more aerodynamically driven when they allow adaptive surfaces in a few years. So, Formula One car is a pretty good surrogate for an airplane. And so with all of those lessons learned from McLaren, I went back to the Air Force. And it worked great. The same playbook worked for Air Force things. So one of the programs, the T-7, was able to build prototypes of fighter-like airplanes. They're trainers. They don't have weapons, but they look like fighters to the average person. They were able to build those in 3 years. That hasn't happened since 1958. It's a remarkable accomplishment due to digital transformation. One of the missile programs, the Sentinel, built over 6 billion digital twins. Whereas in the past, designing maybe 10 different missile systems before you down select to the one that you're going to go make, right? That's taking the Formula One paradigm and going even more extreme. Now, I don't know if the 6 billion were actually needed or if the team was going for style points, but it's a great talking point, and it's completely true. The B-52, one of the oldest airplanes in inventory that the Air Force is going to keep till it's over 100 years old, amazingly, used digital twins to put commercial engines on. The entire de-risking and selection was done via digital twins, treating the digital deliverable as real. And then even in the world of maintenance, just using predictive maintenance like the airlines and many industries do. So having a digital representation of failure modes and making smart choices on replacing parts saved a lot of money and improved readiness. So great, it was fantastic. It worked really well. But, and there's always a but, isn't there? Every one of these was hard. It was hard at first before we got the results. And when I talk with Formula One racing, it was hard. And with companies that I help now when I consult, it's hard. And what makes it hard? Like, there's always something, right? There's always this hurdle you've got to cross. And that is that there are amazing models and simulations in every industry, millions that our lives are connected to. I don't think most people really understand how much their lives are connected in some way to the world of models and sims, because everything that we are using, everything we're touching today, there's a model of it somewhere that was used to create it. And for every company that I've helped, and for the Air Force and for Formula One, the models that they need are not integrated together like the rest of the internet is. It's like the Internet of Things happened, and models and simulations did not become things in the internet. And if you think about it, the internet really doesn't have like physics or engineering in it. It feels like it does because we have navigators in our cars and we cut them on, they tell us how fast we're going. But like your navigator doesn't know if you can say stop in time to not hit the car in front of you. It doesn't have an engine that can produce that result. It's just taking differential measurements and telling you how fast you're going. Right? You can't like generate a live result for weather that takes like current conditions and propagates them a few minutes. You're just taking something that was generated in the past and getting the best fit. If you think about the internet really is mathematics today. Like even things like that we're seeing large language models revolutionize, right? Like text and images, you know, being able to generate features. It's really mathematics, right? If you make a construct that's a feature, it's a mathematical entity, and then you apply it to an image. That image is really a matrix. So it's math. If you don't like math, don't worry. You don't have to understand it. It doesn't really understand how to take those results, create an engine, and propagate it forward. That's what models and simulations do, and they're not connected currently. So maybe a good example is you can ask ChatGPT how to make a paper airplane. It will tell you how to make one, step by step. But if you ask it how far the paper airplane will go if you throw it, it doesn't know, because it doesn't have a way to produce that result, and it'll tell you that. So that's kind of an interesting idea, right? It didn't click for me in the Air Force that it's weird. It's weird to me now that models and simulations aren't like everything on the internet, that they're not like applications on our phone. But it's kind of clear why they're not, right? It's weird, but it's also clear that models and simulations have to obey rules. And we are not able to make one model and simulation to rule them all, right? That would be The Matrix. That's an awesome movie, but we can't make it, right? The universe has like 6 billion, 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 trillion, 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 trillion bytes of processing power just based on what we can see. So no, we can't do that. Even if we tried to do like a subset like the Earth, it's so computationally beyond our ability that we are forced to make models and simulations that just capture a slice of the universe. And we have to make a lot of assumptions to do it because we cannot replicate all of the physics that are happening in this room. And when we make those assumptions, right, it gets difficult to take models and sims that have made different assumptions, different slices of physics, and to stitch them back together in a way that allows us to do what Formula One did, which is manage that error statistic so that you know the result is good within plus or minus a certain value. It's really easy to mess that up, but not impossible. So when I was working at the Air Force, we had really smart engineers who could do it. And Formula One had really smart engineers who could do it, and it was always tricky. And this idea of this digital thread, if you've heard that term, which is like when you thread all of those models and simulations together so that they can act like a little mini internet, it was always breaking. Anytime something changed, right, it'd be like, oh, it's going to let error in unless we make a correction. But smart people do it, and we save so much money and time. It was totally worth it. And I left the Air Force just thinking, this is the cost of doing business. If you want to do digital transformation, then you just get engineers and go do it. And yes, engineers are expensive, but you're going to save so much money, it's worth it. But what I've realized since leaving and being in the private sector is it's put digital transformation in a weird place where, unlike a lot of fields that are being driven by the startup community and venture capital as a way to like have a bunch of people go out and ideate and then the winners change the world, that's not really happening right now. Because those engineers, to connect all those models and simulations together, to even get started to build something, are cost prohibitive for many startups. And the people that are doing the connecting are not really trying to just work on the connection as an endpoint. They're making the connections between models and sims because they want to go build something. They want to go build airplanes or race cars, just like I did. And so it's created a weird paradigm where digital transformation is being driven by big companies. And the startup community is not as present as it would be in areas like AI. And that's what ultimately led me to this, like, someone should be working on the connective tissue, just as an end state, not trying to build something with it, just making the connections easy. And what's been fun is with some help from some great investors and from Eric Schmidt, who's a friend and colleague, former CEO of Google, who was our first investor, we created a company called Astari. It's named after the wizards in Lord of the Rings because digital transformation is magical when you get it right. There ought to be an easy button for connecting things together. And so we have a really cool idea that hopefully will come up here in a second. Boom. That the Internet of Things should evolve, and it should be an Internet of Things and of physics, and of engineering, and of manufacturing, and of the slide would get pretty messy if we wrote all. But the idea is let's bring all of the models and simulations that we currently use to make amazing things in industry, and let's create a way to connect them to the internet so that we can get internet-like functions. We can do applications. We can do AI. Let's find a way to manage all of the error terms so that when a result comes out of this evolution of the internet, we know what the error is and we can trust it. You know, it would be very similar to what's happened in software development, where you and I, we can go start a software company today, and because it's morning, we can probably get some applications deployed today if we're fast and we don't go too complicated. That's how much automation is now available in software development tools today, out of the box. Well, if we could bring models and simulations into the internet, the same thing should be true for hardware in the future. We should be able to start a drone company today and design drones using models and simulations and a lot of other things from the internet without having to be the deep, full-stack developers that understand all the software things and all of the aerodynamics and aerospace engineering. We should be able to do that because it happened for software, and it should happen for hardware too. But you can probably imagine it's not impossible to think about that being true, that you could do it, right? I mean, yes, the assumptions and models and simulations are complicated, but it's not completely unfeasible to think that you should be able to create a technology that allows them to be managed and automated so that you don't have to have engineers to connect them. And that's what we've done in the startup. We've made that our one and only one quest. We focused on that until we made a breakthrough, and we've brought the company out of stealth mode because I have seen, I've witnessed with my eyes, models and simulations behaving just like everything else on the internet. And it is amazing. It is amazing to think about what the future can be. And although we're still kind of stealthy, to give you a little thought experiment about what it's kind of like, is minus the holograms, it's a little like watching Tony Stark's workshop, where Tony Stark in the Iron Man movies, they spend a good bit of time just showing the engineering process, right? And there's a good reason why. It's super cool, right? Tony's like a one-person Fortune 50 company from an engineering perspective. He's building an Iron Man, so he's got designs, and he's throwing them together in his holographic projector, and everything just kind of clicks together, and he can go simulate it, and then he can go make it in his 3D printers. All of that is happening organically, just like things do on the internet. You can tell there's an envisioned high degree of automation, right? It's pretty cool, but we can't do that. Right? That's science fiction, but it will be, well, I guess it is in a fairly meaningful way science reality today, and I think eventually it will be so commonplace that being able to pull in data from models and simulations will be as common as data from things that we don't say Internet of Things anymore. We just call it the Internet because we all know things are a part of it. I think it will be the same. And when that happens, when the ability to do digital transformation commoditizes and democratizes so that companies of any size can do it in any industry, then I think the term digital twin will go the same way. We won't say it. It won't be like a cool thing. It won't be an accomplishment. We'll just expect that anything that we're holding has a digital twin, because why not? And what's so interesting to think about is what will happen? What will happen when more and more of the world has a digital twin that's cooperating with it, like Formula One does today? What will happen when those digital twins get to work together, right? It's amazing to think about the type of innovation that will happen and how fast it can be in areas right now that are encumbered by physical reality and the tax it places on innovation in terms of its cost and timeline. So it's a really, really exciting time to be alive. It's an exciting time to be in engineering. It's an exciting time to be in the field of models and simulations, because this industry, I think, will become a trillion-dollar industry that's connected to every other one, generating value on an ever-compounding level. Now, a lot of people ask, how did we make the breakthrough in Astari? It's very simple, is that we have wizards at Keyboards who do it, very smart people. And we gave them a very specific problem that I realized wasn't being asked or addressed, because I would have been the big customer of this plug-and-play capability. I would have loved to have had this in the Air Force, because it would have saved me all of those engineers. They could have done engineering and not done tool integration for me. Very smart people, empowered, focused, tend to change the world. Now, there's another reason to treat this topic urgently, and that's where I end with most companies when I'm helping them, is that yes, you will go faster, like light speed faster. Yes, you will save money, billions in the case of large programs. And yes, you will lower the environmental impact of innovation, and results from companies like Deloitte that have looked into this seem like innovation actually puts as a pretty big tax on the environment when we need to make things. So that's win, 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 right? That's a reason to go do this. There's another reason to do this that's just starting to happen, is that once you've got these connected digital ecosystems that can model reality nearly realistically, that's exactly what you need to train AI to do things in the physical world. And there's some pretty cool examples of this happening. The Air Force, we trained AI to operate a U-2. They recently just had AI fly an F-16, so piloting, something that AI can do through high-fidelity models and simulations. an even probably more impressive result, Team New Zealand's America's Cup team taught AI to sail, and then not only did it sail better than people, it designed boats that people had never conceived of designing, and then ultimately had to train humans to sail differently to sail its boats. Team New Zealand has won America's Cup 4 straight years. They can never beat that AI, and most people don't know about that. AI's crawled out of the internet and has now dominated a physical thing, better than people will ever be. Expect that in more industries. John Deere, a highly digitally transformed company, has said they are close to fully automating farming through AI. How are they getting their AI capable of doing farming? They have to use connected digital ecosystems to do it. So that's the big ending chapter, is AI is going to get to lead the Internet of Things because we're going to connect models and simulations to it that are going to give it access to, quote, physical results where it can learn to do physical things so it can operate in the physical universe with its feedback and feel like it's operating in the computer. The sailing AI for Team New Zealand knows no difference between digital or physical water or wind. It's all the same to it because it's all the same result with error that's more or less the same from either result. And when that's common everywhere, I think it's going to have us ask the question, what is real anyway? I hope this has given you a few things to think about this morning. It's been a pleasure spending time with you, and I can't wait to hear from some of the other panels today. Thank you.
Turning hardware into software. Music to my ears. Thank you, Will. That's a great speech and a great setup for the rest of our conference summit today. I would also like to welcome District 4 Orange County Commissioner Maribel Gomez Cordero. I believe you're here today. Thank you. Okay, so our first panel of the day is digital transformation and their uses. Please welcome our moderator, Michael Chance, and his 4 panelists to the stage. Michael is the Director of Engineering, Technology, and Analysis for Disney Parks Experience and Products and leads a multidiscipline team which develops mathematical physics models for transportation, ride, and animatronic systems, custom software network applications, and robotics. Welcome, Michael.
Well, thank you, Bev, for that very gracious introduction. First of all, I just want to address something that Will said about not liking math. Did you say that, Will? I thought I heard you say that you don't have to like math. I mean, come on. In this room, who doesn't like math, right? I mean, that's half of why we're here. So, but anyway, Will, that was a fantastic introduction, a great predecessor to what it is that we're going to talk about, and sets a lot of the foundation around what we have to talk about. I was asked also to provide a definition of what we think of as digital twins in the world that we're using in our data analytics solution here at Disney. What we think of a digital twin is a virtual entity that mimics a system or its components' real-world performance via computer simulation and real-time sensor data and can be leveraged to improve decision-making. I think that followed very closely onto Will's keynote, and I think it'll kind of set the stage for what it is we're going to introduce now. So I'll go through individually for each one of these panelists, and they'll have an opportunity to talk about their technology and how it can be planned. So first we have Sean Fitzgerald, Senior Account Executive of Mobility at PTV Group. Sean.
Is this on? Can you hear me? Awesome. I am the Senior Account Executive at PTV Group. We're one of the bigger and more famous companies you've never heard about ever in your life. And what a Senior Account Executive means is that I'm the oldest person that sells stuff in my company. But I am one of the world experts in the PTV products, and I'm in Detroit. So I'm going to go through as quickly as I can because we have about 24 products. So I'm going to focus on the ones that are only relevant today. So if you want to roll that bean footage, we can go ahead and go through it. PTV is all across the world, but I'm at PTV America, and we've recently joined with Econolite to form a company called Umovity with a mobility for humanity. In relation to our topic, we make two products called Vissim and Viswalk, microsimulation, and we are the world industry leader in what we call agent-based simulation. Agent-based simulation means a lot depending on who you are, but basically every entity within the software has its own behavior, its own decisions. Every wall, everything is something, and it's represented in reality with its own behavior, whether it's walking behavior, driving behavior, surfaces of vehicles, wall textures. Microsimulation is not a video. We're not rendering things. These are all native to the software. You just go in 2D or 3D. This is the Detroit airport, and this is a pretty common use of our software to kind of gauge what a product will look like in reality, whether it's an interchange or an airport. We recently redesigned the Serbian airport in Viswalk. We built the entire 90,000 square meter, but it's not only about the picture. Every device, every vehicle within the Vis and Viswalk software is real, whether it's door opening times, walking behavior, distances, calculations, is all realistic, as we call it. It's one of the oldest uses of the form digital twin in the transportation sector, and you can see why when you take a look at the video. We've integrated the 2D and the 3D into one platform. That's literally the software running at the same time. But both in the engineering and in the stakeholder view, as well as bringing in things like the FDS, the fire system, to model evacuations. In this case, you're looking at heat exposure. You can do particulate analysis. And when you're looking at the ability to model agent-based simulation and particulate analysis, you start to understand why these things work well together. Here's an example of our outward SaaS products that take our data to create this is called the Publisher, where you can bring transportation data directly into kind of a Google environment where you can interact with each other, look at results, bring it back to the model, talk about it. Our free SaaS products like PTV Access, which looks at accessibility of walking, driving, persons with mobility access, and all of that stuff around the world using all of our data partners and our ranking scores and giving the ability to have data available. Our Lines SaaS product, which allows for real-time integration with PT services in order to build and make changes on the fly in your traffic management center. And our newest thing, which is the PTV Optima product, which brings it all together with our machine learning and our AI and our data partners to bring in real-time sensor data, as well as calculate it through propagation theory through predictive analytics. Using that, we're able to do transportation studies both in the real world and in the fake world. Think you're having the Olympics, but you're wondering what happens if a bridge is closed? What's going to happen to the traffic? So you can take the real-time data in the real-time situation and run fake analysis to see what will happen in the real-life situation. And using what we know at PTV about predictive analytics and mobility, we're able to look at things with a high amount of safety and security. You're actually looking at the real model of York, England, which is in their traffic management center. And this is just a small amount of what we do at Umovity PTV Group. So if you want to know more, my email address, Sean.Fitzgerald at PTV Group, and I will be happy to tell you all about it. Thank you.
That's great, Sean. Thank you. Thank you so much, Sean. That was a great overview. And fits right in, again, with what we're talking about, doing modeling, right, and how it's critical when you think about digital twin. So next we have Sheng Li. He's with Senior Industrial Manager at the MathWorks.
Okay. All right. I'm Tony He from MathWorks, creator of MATLAB and Simulink. If you are engineering, I think most of you heard about MathWorks. So today I'm very happy. Thank you for Michael and the host put this panel together. I'm happy to share my knowledge and experience with everybody. So I put this video together. So let's watch the video first.
MathWorks has been supporting companies in almost every major industry. This experience gives us a pretty good idea on what companies are doing and where they are going. Digital twin is one of the areas we have seen many of our customers are embracing and getting value out of. For example, Schindler, an elevator company, used a digital twin for hardware in the loop as part of their digital transformation journey. Siemens Energy developed a gas turbine digital twin for performance optimization and diagnostics. Atlas Copco, a leading provider of air compressors, leveraged digital twin throughout their complete product lifecycle. Today's video is based on what we have seen from these customers and what they had to do to become successful in their digital twin journey. There are many different ways to look at a digital twin. This diagram shows a three-dimensional view of a digital twin, with the dimensions product lifecycle, digital twin workflow, and maturity. We will talk about these dimensions and go over the key capabilities needed for a successful digital twin application. The first dimension is product lifecycle. During the product lifecycle, OEMs develop the system and operators operate the system. We have seen digital twin use cases throughout the complete product lifecycle. During product development, model-based design has been used extensively by many OEMs. It provides a solid foundation for building digital twin applications. In many cases, model-based design applications are considered digital twin use cases. With model-based design, models are the single source of truth and are used to design components and systems. These models can be linked to requirements to ensure the system will do what it needs to. In this way, we start to build a digital thread. The models can then be used to automatically generate software for the production system. You can generate code in different programming languages and platforms. The same models can also be used for verification and validation, not only during the tests of the real system, but also on virtual representations of the system. And finally, in operation, the same models can be tuned to represent a single asset in operation, becoming a digital twin to support the operation and maintenance of the asset. Many companies across industries are using this systematic approach, an approach we call model-based design. In the product lifecycle dimension, we see many successful digital twin use cases. No matter which use case, there are 5 major steps to follow. We will talk about the key digital twin capabilities needed for steps 2, 3, and 4. In order for modeling and simulation to be effective, you need to be able to combine components and systems from multiple domains together. For example, by modeling and simulating components that run either continuously, in discrete time, or are event-driven, you can combine those components to create complex systems, such as communications or radar systems, which can then be further integrated with data-driven models to create perception and autonomous systems. And all of this can be done today with MATLAB and Simulink. And there's an entire ecosystem of products and solutions that work together with MATLAB and Simulink. With model-based design, the models are continuously tested and validated. When shifting verification and validation activities to the left, it makes it easier to find errors as soon as they are introduced into a design. Digital twins can be deployed to different places across the operational topology based on their application. For example, putting digital twins into the embedded devices on the assets generally has the fastest response time. Many times, its purpose is control and protection. Putting digital twins on edge systems enables many new applications while still maintaining a good response time. The connectivity to cloud and big data is also a digital twin enabler across the operational system. and by running what-if scenarios, risk can be mitigated and operation can be optimized. There are many different systems that might be involved in operationalizing digital twins. MATLAB and Simulink integrate with the end-to-end technology stack for the smart assets, edge systems, and IT/OT systems that you choose. Now that you've built a digital twin and have connected it with your physical asset to support your decision-making, you may wonder, what is the prediction accuracy? And how much should I trust the digital twin? To answer those questions, we need to look at the digital twin from the third dimension, maturity. This dimension is very important. You cannot have a successful digital twin application without truly understanding this dimension. The capabilities needed for this dimension are maturity assessment and risk management. Now, let's summarize. What are our key takeaways? Digital twin is a major trend. It is a new way of thinking and working in the era of digital transformation. Digital twin adoption is a journey. It takes people, processes, and technology to become successful. Partnering with companies that have experience and expertise will accelerate this journey. MathWorks has supported many companies building up their digital twin capabilities, and we are here to help you succeed in your digital twin journey.
Thank you, Shengli. That's great. Thank you. And next we have Danny Williams, who is the Technical Account Manager over at Epic Games.
Good morning. Thank you, Michael. Thank you, everyone, so far for the great discussion. Really enjoyed Dr. Roper's talk. So you all might be wondering what the heck a guy from a game company is doing here. Maybe to redeem my credibility, I have been in the simulation industry for close to 20 years. I joined Epic about 2.5 years ago. And my reasoning for moving in that direction, away from what I'd traditionally done in more traditional government defense-related work, was a convergence that I started to notice that has been talked about for a long time, but hasn't really been realized for a long time. And you can cue the video. And that convergence is this idea of using game engine technology and using high-quality photorealistic technology has been around for a long time. The idea of it's been around for a long time. But the actual implementation of it, the actual ability to use it in meaningful ways and in a way that was cost-effective and not just for the glitz of making something look good, hasn't really come to fruition for a long time. Again, it's been around for many, many years. It's been talked about throughout my entire career in simulation. But it's not until the last maybe 5, 6, 7 years that it's really started to move in a direction where people are seeing the ability to use technology that is photorealistic, being able to render things in photorealism, but also being able to do it in real time. So this convergence of what our goal is in simulation frequently, which is to run real-time environments, real-time simulations to simulate all the different things people are talking about today, but also do it in a photorealistic way. One of the best examples I've seen of that in the work that I've done is working with Tesla as one of our customers. And Tesla has an interesting use case for our technology, and that is to make the best video game that a human will never play. So they take the Unreal Engine and they build a digital twin of the environments within which their car drives. Their cars collect huge amounts of data, and from all the cameras that they do, they have the ability to pull that data in. They then want to be able to recreate those environments in a digital world. And then in that digital world, they want to drive the car through it and make the scenarios different or harder or cloudier or darker, whatever the different changes they want to make to the environment. They can do that using the Unreal Engine. And they can do it so that they can drive their vehicle through those environments in a photorealistic way, something where the autopilot system doesn't know that it's looking at a digital twin of the world. It thinks it's looking at the world the way it does when it drives every day. And so the Tesla team has done some amazing work taking the Unreal Engine and converging on this idea of photorealism and real time, and they can run the actual autopilot software through that environment and do all kinds of different tests and trade studies. So that's really one of the more cutting edge examples, and we're seeing it, as you saw in the video, across a bunch of different industries. Tesla's doing it, the Space Force is doing it. You mentioned John Deere. John Deere is another one of our customers that's digitizing all of their environments to create digital twins that answer a whole bunch of different questions. So the convergence there is really something remarkable. Again, it's something I haven't seen until somewhat recently in my career. And then the Tesla example also brings up the next kind of very interesting point of convergence, and that is the speed at which we can create these environments. The idea of creating a geospatial representation of a particular part of the world is not a new idea. People have been trying to do this and doing this for a long, long time. There's data sources that exist to pull elevation data, imagery data, all kinds of different information about the real world into a digital environment to then do whatever kind of testing, whatever type of analysis you're looking to do. But it has always been a very time-consuming, a very complicated process, a very expensive process. How do I collect the data? How do I correlate that data across multiple different sources? And then how do I use that in a simulation environment? And so the other really interesting piece that I think we're at today is the speed with which we can do that. That is changing at a level that is unprecedented in terms of the simulation industry. How quickly data can be ingested. I remember building 3D environments early in my career where the data that we were using was 10-year-old data. It was imagery that was collected 10 years ago, maybe 5 years ago. Beyond that, it was really hard to find. This is 20 years ago, so it's gotten better over time. But now we're talking about being able to build digital twins of a particular part of the world in days. This is 2-day-old data, and in some cases, in the extreme, hours-old data. So the speed at which we're able to get that data into these environments is remarkable. Going back to the Tesla example, they have the ability to pull up a map of San Francisco and click on any street corner, any part of the world, or any part of the map in San Francisco, and immediately create a digital twin of that area. And it does all of that on the fly because they've got all of this data, and they have a workflow that pulls that data into their environment in seconds, and then they're able to run through whatever scenario they want. So very, very interesting time, in my opinion, to be where we are in simulation. I think we as a company are looking at the foundational technology where we can enable the real-time photorealistic environments for anybody to go build their digital twin, their simulation environment on top of. So looking forward to the rest of the discussion, and back to you, Michael.
Thank you, Danny. That was great. Yeah, interesting times indeed. I think you're right. It's just absolutely one of the most exciting times looking through these. It just reminds me of all of us that have been through this passage and seeing what this has become now is just really exciting. So next up we have Vitor Pereira. He's the Senior Product Sales Manager of Digital Twin Americas at ANSYS.
Hello, good morning, everyone. Good morning, Michael. Thank you so much for the invite. Thank you so much for the discussion so far. As you are familiar with modeling simulation, you may or may not know of ANSYS. For the ones that do know of ANSYS, you know that we've been around in the modeling and simulation space for over 50 years now, primarily in the product development space. And you also know that we have high fidelity and very costly models that take some time to run. So you may be asking yourself, what are you doing in a digital twin conference, right? And the answer is, what we're doing here at ANSYS and what we've been doing with our customers is taking those very same models and developing and streamlining workflows to bring those models to bear in a much faster runtime space. So the concept of hybrid digital twins, being able to take complex high-fidelity models, create reduced order models of those, integrate them with data to either calibrate or even model residuals, and then finally deploy those into platform-agnostic deployable units that can be easily integrated into any IoT or edge stack, which is what we're going to be focusing here on the panel. So if I can get some help there just to play the video.
Digital twin is a virtual representation of a connected physical asset made possible by combining advanced simulation and analytics. Digital twins are used to reduce maintenance costs, anticipate potential problems, and improve processes in operation. The best digital twins are accurate, adhering as closely as possible to the actual physical behavior, flexible, predicting behavior across multiple operating scenarios or product variations, adaptable, adapting to changing environment and conditions, and scalable, being built from rapid, automated workflows. ANSYS introduces Hybrid Digital Twin. Hybrid Digital Twins, the best of machine learning and physics. ANSYS Hybrid Analytics is a toolset for combining data and physics modeling using machine learning techniques to update digital twins in operations. Hybrid Analytics enables real-time monitoring, predictive maintenance, and performance optimization of systems and processes. Operators reuse engineering design in operations, and engineers gain field insights learned from data for the next design cycle. Used across a wide array of industries, from virtual sensoring to learning unmodeled physics, hybrid digital twins help companies solve many challenges. Do more with the data you already have with ANSYS Hybrid Digital Twins. Get your free trial.
Okay, so if you're interested, you can come and talk to me, obviously. But I'm going to show a little bit on how, right? So one of the key elements of the technology, if I can break down the technology into two main steps there, it's like one is about building and validating, the other is about scaling and deployment. So on the building and validation, we have come up with what we like to call Twin Builder, which primarily enables you to create these reduced order models from existing 3D multi-physics designs and or test data or different types of models that you have out there. Now, Twin Builder is also able to help you understand and visualize how these reduced order models compare with the original models, the concept of uncertainty quantification that was already brought up this morning, to understand when how good of an error or how acceptable an error do I have, right? But then eventually you want to get to exporting that twin out, and you want to bring it to use it with other components. So can you integrate with models from different solvers, models from different levels of fidelity? And then the answer is yes. That's another aspect of Twin Builder. Think of it of a system-level modeling tool on asteroids, where you can create these ROMs but partner them with other types of components. Finally, some of these models may or may not be accurate from the get-go. So, there's concept of missing physics. There's concept that maybe the models that we're trying to twinize are equipment that have been on the field for quite some time. So Twin Deployer first helps to bring techniques that allow you to take test data, take operational data, and apply Bayesian inference models or Gaussian techniques models to be able to take that very same operation and test data and enhance the fidelity of your models. Now, the other aspect that is very powerful within Twin Deployer is the ability to create these platform-agnostic type of applications. So can you create these web apps? Can you create containers? All of that at a click of a button so that they are easily deployable into your IoT or edge stack, right? So I guess the main power here that I'm trying to convey is not just the ability to do these things, but do these things in a streamlined way, which is some of the challenges that we've been all talking about is, hey, has digital twins been possible for a while? Yes. But as far as streamlined workflows, processes, integration points, a level of maturity between all the different offerings in the ecosystem, that's something that we're moving towards now, and it's a journey like everyone in the panel has brought so far. So here's just a few examples. Again, if you guys want to learn a little bit more, want to know a little bit more about how we're working the hybrid digital twins in this space, feel free to reach out to me after the panel. Thank you so much. Appreciate it. And let's go to the discussions.
Thank you, Vito. So, and I think you can see kind of the breadth, right, of industries across when you say digital twin and what it actually means. It covers so many different areas of how we end up working in all these different industries. So I have a few questions here I want to speak to the panel about. And like I said, I like to think of these folks as like doers, right? These are people on the front lines trying to apply these principles to real world problems. So Sean, I'm going to start with you, if that's okay. Can you talk a little bit about how you see this technology being accepted and embraced in both government and private enterprise? Are there any challenges that are holding back the rollout of digital twins into the general engineering and science community? And what are they, and how should they be addressed?
Well, can you hear me? That's a really interesting question, because from our point of view at PTV, digital twins have always been accepted for 20 or 30 years now. The real question is, what is a digital twin? Because 30 years ago, when VISM was invented in Germany, A digital twin was just representing reality in any way, shape, or form. It was a DOS program where like a letter would move across the screen representing vehicles, and that was amazing. And then the government wanted GEH statistics for calibration, so we worked with them to do that. And every step, it's been either us suggesting the government or the government suggesting us, and it's been an iterative process. So my main suggestion is what PTV does, where we equally work with our customers in the private and the public sector. We figure out what both sides need. We get them to talk to each other. We have summits where they communicate with each other, and much like I was discussing earlier with the panel before we started, a lot of this has to do with expectations. What do you want? What do you want to simulate? What do you want the result to be? Because if you want to know what an intersection is going to be, building a whole city is going to cost a lot of money and give you nothing. So from our point of view, it's already accepted. It's about keeping up with the trends, about making sure that your software is able to replicate what the government requirements are to prove that it is what you say it is. And I think the biggest hurdle is starting to be overcome now, and that's price. 5 years ago, making a photorealistic thing in 3ds would probably cost $10,000 or $20,000 a go, whereas I can click the 3D button in Vism to bring it into 3D. It may not look photorealistic, but for a lot of people, it's good enough. It costs 1% of the price. So governments often don't like to go with digital twins just for their cost. They'll go for the cheaper option. It may not be the good option. So it's important to communicate needs, expectations, and make sure that everyone's on the same page.
I'll open this up to the rest of the panel, too. Does anybody have any other comments you want to mention?
Yeah, maybe I can add something. So I think both government and the private companies are embracing this digital idea and try to get value out of it. And many times for government or the other companies, this digital twin is part of the digital transformation or digital engineering initiatives. So regarding the major challenges, I see several major challenges to spread out these digital twin applications. The first one is always to start, right? What's ROI, return on investment? When you try to have a digital twin project, the management or decision maker always ask, what I can get out of it, right? That's the first challenge. The second one, even if you have a good digital twin project, have good success, but how to scale it up from 1 to 10, 10 to 100, or to different business unit, and also transform a business model, right? That's also kind of very challenging task. Involves many change management, those kind of stuff. Number three, so if you remember the video I showed earlier, the overall digital twin workflow is all the way from modeling, simulation, testing, validation, deployment. It has so many pieces of technology involved. To understand the overall landscape, it's also another major challenge. So, the best way to handle it, it's always talk to people who have done this in the past and come to this kind of event to hear, to listen, and also partner with the companies who have done this in the past. It's going to accelerate your transformation journey.
Yeah, one of the things I always remember is that you can't do this alone, right? There's a lot of very complex things that you have to partner with and speak with others. Yeah, that's a great point. Dan,
I would just add, exactly on that point, I think, one of the biggest challenges I've always run up against in my career in simulation is the convincing groups that want to develop something themselves internally. An internal engineering team that says, we don't need to go get a tool or buy a product. We can just develop it ourselves. And lots of great technology and products and capability has come out of ideas like that. But I think understanding what the ecosystem of available capability looks like and where you can leverage existing technologies and not reinvent the wheel, but still go build whatever your unique capability is. I think that education process is important because I do think the whole idea of being able to do this quickly is affected by the existence of these tools and lots of other people that make great technology. And I think that's just an important, it's always been an interesting hurdle in the industry.
Yeah, and there's a lot of sharing of the information, the underlying technologies and everything that I think has really advanced everything. Yeah, that's great. So, Cheng Li, let me go on to you with this next question. Where do you see the most beneficial next use case of digital twins, and what industries would most benefit?
So I have seen digital twin use cases in all the industries, right, across many industries. From the product design to the testing, validation, operation, and maintenance. The most beneficial use case I have seen is if you can leverage your digital twin throughout the complete product life cycle, all the way from beginning to the end. So that you get the best value out of it, because you can reuse your models you have. You can establish the traceability or digital thread. You can also leverage your model for your customers, right? You can transform your business model. So that's, I think, the most value. I think all industries have this kind of potential. And also, if you look at all industries, the way I look at a digital twin is more it's two categories or two personas. One is the OEM who develop equipment, the system. The other one is the operator who operates the system. So those kind of two different scenarios. The capability they have and the role they play in the digital twin space, how much value they get out of the digital twin are quite different. So that's the way I see it, how to put the industry into different categories.
Yeah. So I think, one of the things that we always talk about is like reuse, right?
Right.
So, how best can you take all this investment that you made in Vitor? I think also alluded to this earlier. You've got this collection of all this data and the models that you've built. How best to kind of can you use them?
What you have.
Right. Yeah, exactly. Because then that way that can help, the whole ROI question again and everything that you go back to. The more you can reuse that and come up with different use cases, that initial cost that came up with that, you can blend that and spread that across all these different ways of using it. Yeah.
If I could just
go ahead,
one
Dan.
more thing. I think one other important aspect of this that is, again, I think a trend that we're moving towards is the democratization of the technology and the data. Again, going back to like a geospatial example, it used to be really hard to get geospatial data. If you wanted, some other part of the world, it was really complicated, expensive, time-consuming to get that data to use in an environment. You can go today to any number of different services and companies and immediately have that data. And geospatial data is one example, but that's true of all kinds of different things. I mean, counties and states around the nation are putting up all their GIS data for everything. Their sewer systems, their traffic lights, all that kind of stuff. So all of that data being available, I think, is an important part. And then the technology that can then use that, and anybody with an idea could go and say, I'm going to build a digital twin of something. And I think that's an interesting evolution. That it used to be a lot harder.
Yeah, go ahead.
I mean, I agree wholeheartedly. I mean, integration and partnership is the way to go. When I started modeling about 20 years ago, like the knowledge you had and the information you had was almost like a secret that you kept. Like, I am the modeler, I know how to do this, you don't, right? Exactly. So the problem that we ran into, and this was to preserve salary and jobs and stuff. I mean, there wasn't a lot of, a young person could come in, I know what you do, and I will make half of what you make, right? But what you see a lot of in the last 2 or 3 years is companies coming together and saying, I do this well, you do this well, let's not fight, let's make communication, I mentioned that, Umovity is our brand name that PTV is under. It also has a company called Econolite, which makes sensor data. They make a solution for ingesting the sensor data. We don't have that, and one of the biggest problems with transportation models is data. Garbage in, garbage out, as we say. So through that integration, suddenly we now have a tool for getting the data, for processing the data, and analyzing the data all in the same community. They benefit, we benefit, you benefit. And that's really the next step, I believe, to get this going.
Yeah, that's an excellent point. And like you said, I think the more that we end up talking and working together, the more we've been able to advance. And everybody, when it goes across the finish line, everybody ends up helping each other at the end. I'm going to come to you last, I think, Dennis, if that's okay. Danny, sorry. But I'd like to go on to Vitor real quick and talk about this last question, and I'm going to come back to you, Danny. So in artificial intelligence, machine learning methods have been made significant advancements in recent years. Do you see AI ML as something that can be applied to digital twins, and if so, how?
I definitely do. In fact, it was, it's a whole topic of the video that we saw earlier. So what we're doing with machine learning at AI at ANSYS today is and how I see it being played out. I like to separate these two in two main buckets. So there's like top-down approaches and there's bottom-up approaches, right? So at the bottom-up is, can you use AI machine learning models to try to calibrate existing physics models to compensate for missing physics, to compensate for aging and performance, that sort of thing, right? So we all know as engineers that our model is only as good as the setup and what we can put it there. And sometimes there are gaps and the data can help fill that gap. Now, that machine learning can also help to streamline some of these models so they can be packaged into something that can actually run side by side with an asset that is operating. Otherwise, these models will just live in somebody's computer and that's it, right? Now, on the top-down approach, it's more about, can we actually leverage machine learning and AI particularly to evolve the models such that now we're not necessarily training models, there's happening unsupervised learning, and the models are actually to learn alone without being fed data. So that's an area that ANSYS is heavily investing on right now, not just for digital twins, for actually modeling and simulation in general. And between these two, that's how I see the synergy. In my whole, I've been in the digital twin space for now over a decade. And I like to say that there was never a meaningful twin that I built out there that did not have an element of physics and an element of data. They both need to coincide. And that's how I see it.
Yeah, I think there's a lot of really interesting work in the unsupervised learning space. I think. Yeah, right, go ahead, Sean.
I mean, you brought me right into a point that I was hoping to bring into. I think the biggest problem in the industry is everyone thinks that AI and machine learning is going to save the world, right? We're going to create this brilliant thing that's going to take over the engineers' jobs and all of that. But we really use machine learning for two reasons. One is what we call propagation theory, and that's to fill in the gaps, right? Maybe physics is a little bit more boring when it comes to cars, but when you have sensor data, I mean, if you think about it, most cities just have the corridor right down in the center of their street with a couple of cameras, right? So what we use machine learning is to fill in all the gaps and make decisions when a sensor goes down, figure out how to fill in the gaps. And then we're also using machine learning for safety, where we can use our Optimus system to bring police or fire resources to certain areas. We found that having a cop in a place reduces accidents, or having a cop in another place clears accidents faster, which reduces congestion, right? And we're using machine learning to figure out where to send them over time as traffic is changing throughout the day, as well as the hope to eventually make the sensor be the checking point and not the data. And that's where we're eventually going, is using machine learning to have the data be the reviewer and not the star of the show.
Yeah, one of the things in conversations I've had with people too is, don't forget, AI/ML is a helper, right? It's not going to be something that ultimately ends up taking over, but it can be get us to this next big step that we're making in humanity. I always like to say, dogs were here to get us to where we are now. AI can help be this next big step. But yeah,
my wife in HR says your job is not going to be taken by AI. It's going to be taken by someone who uses AI.
Yes, it's a great. Yeah, go ahead.
Maybe we can also summarize the AI applications, what I see. The first one, of course, if you look at the digital twin modeling, you have physics-based, data-driven, AI-based, or combinations, right? That's one way to use AI. The second way for AI also, for many digital twin use cases, like predictive maintenance, I see some customers, they use machine learning for to classify different problems they have, right? So those kind of applications, it's also AI. And the third one is come back to the three-dimensional view I showed you earlier in the video on the maturity risk assessment. The maturity level, back to Victor said, the digital twin also have an evolution path from very basic descriptive to the diagnostic, predictive, prescriptive, and autonomous. Right? When you get autonomous, have some kind of AI element into it. And also on the risk management side, AI could support our decision making. So those several three areas I see AI could help on the digital twin applications.
Yeah, yeah, excellent. So Danny, if you could help us out here with this last question, and then we're going to open it up to the audience here too. So thinking both in the short and long term, where should digital twin technology developers move toward? What requirements should be considered?
Great question. I think we were talking about this earlier at the table. I think one of the important things about digital twins is to really define what question you're trying to answer. You know, why are we developing a digital twin? Again, to Dr. Roper's point earlier, creating an actual, complete representation of the real world down to every physical thing happening in this room, to include sound and everything else. That's a really complicated thing and something we don't have computational power to do right now. So any digital twin that gets created has to make some assumptions and some trade-offs on what you're doing. So I think it's important to talk about digital twins in that way and say, I am building a digital twin that is answering a set of questions or doing a set of analysis, for whatever my problem space is. And so I think it's important to think about it that way, and then that helps sort of break down what technology and expertise you need to bring to the table in developing that.
Yeah.
Does it need to be photorealistic? Maybe not. Does it need to, represent, audio in the real world? Maybe not. All of those different kinds of questions, I think, are really, really important to ask.
Exactly.
Because we aren't at the matrix yet. And I think we're getting there. We're moving in that direction. Mm-hmm. And one day we will be. Probably, maybe not for a long, long time. But so I think that's just an important part of it is what questions are you trying to answer? And what technology do I need to bring to bear in that effort?
Yeah, the right tool for the job, right, and the right level of accuracy that you need in order to be able to do it. Yeah, exactly. Go ahead.
If I may, so one of the things that, and I think we alluded to, one of the challenges that I see, not necessarily on the acceptance, but maybe on the adoption, is around culture, right? So yes, you may have technology, yes, you may have workflows, but if the culture is not there to actually apply these and use these, then we will see what we saw decades ago, industries taking years to actually adopt modeling and simulation to stop building and breaking, right? Or to minimize building. Same thing applies to digital twin now. And I think in that sense right now, to get faster adoption, to get that culture, events like this, to have conversations, to understand where the gaps between different industries and so on and so forth are very relevant. But it's also relevant on the development side to bring the techniques and the technologies and the workflows to a level of maturity that people are like, okay, this is easy enough, I actually want to give it a try. Right. So short term, I see that. And long term, I actually see an opportunity, especially going here with the panel and all the great technology that's been exposed, is the concept of bringing these twins to the metaverse, right? So how can you, right now we have AR, we have augmented reality on one side, we have physics results on the other. How can we make those two together in the metaverse? So you can see augmented reality played with temperatures and stresses at the same time. So you can do the Iron Man vision that was painted earlier today.
With the model kind of being that center, right? Yeah.
Exactly.
Okay,
so
well, sorry, yeah.
So just add to what you said earlier. So several areas I think we still need to continue to work on. The first one is the integration, interface, right, those kind of areas. But second one also the IP protection and the security. Because digital twin is a really software product, right? You can take and use it, and how you can protect your IP. So that's, I think we have to work on this area. And maybe the third one is still on the risk management and maturity assessment.
Yeah.
That's still need a lot of work.
Yeah, I really like that. We've talked about that. Like, we want people to come to the table, lock it in a box. We don't want to see what's in your model, but please bring it to us and we'll use it and then, manage it. Yeah. Okay. So I could talk to y'all for another few hours on this. This is a great discussion. So with that, I just want to go ahead and open it up to the audience. We have some time for some questions, and if anybody has any questions. Yes, we have one right here. So there is somebody coming by with a mic.
Good morning, everybody. My name is Andrew Jan. I'm with Uptech. We particularly focus on cybersecurity. I think we're talking about data from Dr. Roper's talking about this morning. we collect all of the data from digital size to the car size right now today. Particularly, we running from all the data from our local database to the IoT, to IIoT, to the cloud base right now. So I want to have a question here. For all of our commercial, we open up our data. They collect all of our data from our regular computers to our phone, to our mobile device, and now to our EV, which is electronics, the vehicles right now. So how could we protect our data to make sure our data could be more confidential? Personally wise, how could we keep the data more integrity-wise? For all the commercial product come out, they could read up and protect not only our personal data, but make sure the data is not being manipulated or being used by something else. So I want to have our panel to give us a little bit of the concept for the future, particularly from our digital twin. How could I apply this particular field? Thank you.
Yeah.
I'll quickly start. I admittedly have very little background in cybersecurity and data protection, but I was at an event at ITSEC last year, and we had a guy from Qualcomm talking about augmented reality and the idea of putting on a pair of glasses and walking around and having that pair of glasses collect all kinds of data around you, sound, video, all of these different things. And they're putting a lot of thought into what does it mean to protect that data, but also how can I use that data. It's interesting because they're in the middle of it, and I think they still have a lot of outstanding questions about what that means and what the models look like. But there are working groups and people coming together to try and come up with a consumer data protection architecture that helps a user understand when I pick up a piece of technology or start to interact with a piece of technology, or I'm using something that's taking data of mine, helping me understand what that means, from a data protection standpoint. And so there's a lot of great work going on in that area. And I think when you start talking about augmented reality and the metaverse and all these different things, it brings up a whole new set of questions. But it's definitely an interesting topic.
Okay, that's a great summary, Dean. Yes, anybody else? What? We have one down here. Yep. They're coming.
Hi. My name is Liv Weaver. I'm with Intuitive Technology and Research and Technology. So you discussed propagation theory and how to fill in those missing gaps of data with machine learning. And I'm curious, how do you manage or combat bias in that synthetic data that you're generating? And with that, if it's greatly screwing your results or giving you a negative bias, what are some methods that you can use to combat that and also preserve the integrity of the input data?
So did everybody understand? Yeah. So I think the question was around, we were talking about the filling of the data, right? So you've got those holes, right, that you're ending up using that I think it's an integrity question, right? You want to make sure that that data is, that you're filling in the gaps, but are they good filling in the gaps? Are they bad? What's the KPI? What's the performance index you can use to look at it and say, hey, I did a really good job of filling in that data?
I think it's really important to first establish what you're doing, because on a transportation network, if you're off on your travel time, oh shoot, I have to wait in a queue a little bit longer. If you're off on figuring out, the thermal density of a certain kind of metal, it might explode in your face, right? So a lot of the stuff we're doing is very experimental, but luckily, no offense to human beings, but driving is one of the most successful social experiments of control in the history of the world. There isn't a whole lot you can do with driving. There are rules. There are expectations. If you have two signals that are both saying that the road's going 40 miles an hour, there's no way in hell that the next segment is going 250 miles an hour, right? There's understanding, and at the same time, you have to accept a certain amount of risk. Computers don't know things. When we were doing genetic algorithms for signal timing optimization, it told us 5 seconds was the optimal signal time. because computers don't know about startup lost time. They don't know about people checking their cell phones in their laps. You know, so it's about how important the data is to be right. Transportation data in itself within 15% is considered accurate. 15% is huge when you're talking about mechanical tolerances. So, I mean, that's the first step. But I think a lot of this stuff is so new, there isn't really a calibration to go against. You know, people always ask me how to calibrate pedestrian simulation or airport queues. There isn't any manual. We're making it up as we go along, and we're...
I think, you know, Sean, I think you hit on it there, and I'm looking at also my ANSYS and actually even, you know, Unreal and MathWorks friends here. You know, when I go back to thinking about models, right? So you have a priori knowledge about the environment that you're running in. Like you said, cars can only go this fast. They're not going to do that. I think at Coleman State Estimators, right? When you build those filters, you put that in a model, and then when you're looking at the data through there, it's going to filter it based on what that model is. And so that's one of the integrity things. So I don't know if you all want to follow up on that, or...
Yeah, we can add a little bit. I think I agree with what you said. First, understand what you try to do. And the data are going to depend on what you try to do, what you try to achieve. For example, the location of the measurement, right? The frequency, those kind of stuff also matters. So if you don't have good understanding of what you try to do, if you look at data, it may not mean anything. That's why I'm strong. So you need to have a good engineering background to understand the data you're getting. If it's just data scientist, that's something you're lacking, not a domain expertise. That's why for engineers, if you have the domain expertise and the data analytics, AI capabilities, that's the best combination.
Yes, exactly. That a priori knowledge, right? That early understanding of the environment you're operating in. I don't know.
So what I would add to everything, and I can echo everything that has been said here, right? It's first about trying to understand the problem that you're trying to solve, what tolerances mean for you, what level of risk is acceptable, what level of error. And then through that is a level of understanding of your data and your models. And for an instance, you know, there are situations in which perhaps calibration may not be the best technique because you're altering your model and you're not necessarily sure unless you put boundaries around it if the calibration is around good data, right? So you may be tainting with your model. Now, there are other techniques available. Calibration is one of them, but there's definitely other people exploring, for an instance, the concept of fusion, right? So can you preserve original models, original results, and model the residuals? That way, you're not really affecting or tainting with the original models. You're preserving them, but you're creating an additional model that sits on top of it that actually models the residual. And that opens up a little bit about flexibility on how and how much and when should you apply that correction model on top of your original model, right? So there's uncertainty quantifications, uncertainty propagation techniques, and that are obviously helping engineers to make those decisions.
Yeah, I think the good news here is that there's so much great science and math that has been done around this to help answer that question. But like you said, like that dual model approach is another way to do it. That was great. Yeah, I got one more question. Yeah, go ahead. Real
Just
quick.
a quick anecdote on this topic that I've been waiting years to share. When I was working in New York, Google opened the Flow Analytical Lab in New York, and we all said, oh, in 5 years, we're all going to be out of a job. Because their express purpose was to create a AI transportation analytics model, basically our software, but no human beings. They failed miserably. They closed the program. They got it out. Inherently, and this is why AI is only a child, there is something inherently human that is necessary to look at the data right now and to make sense out of it.
Yeah.
The computer just couldn't look at transportation data and give you a result. There still needs to be humans looking at the results of that AI technology.
Yeah, and again, going back to that point, right, about human context around AI, ML, and what it is you're trying to do, it will not give you the perfect answer. Okay, we've got time for one last question. Oh, got one over here. Okay. The microphone is running its way to you right now. So.
Thank you for being here. Link Parikh, Rocket Technology. I started this company, even though we're in a lot of those domains, from a design engineering perspective, not what can we do with AI and software and those kind of things. So every time, and there's an IBM conference right next door as well, everywhere you see the word design. And every time you were speaking, and appropriately so, you kind of ended up with a human has to make the decision, and that's really mostly a design engineer. And so what is your opinion on that perspective? We talk a lot about tools for humans, but that human literally, most of those humans are literally design engineers. We've lost the design engineering practice. There's almost no design engineers left in the government. Will, you could tell me yes or no on that. But the design engineering practice is really was driving the life cycle of the digital twin. Nothing has changed for 10,000 years. So I would love to hear more about how you're teaming up with or how you're dealing with the workforce challenges of bringing in that design capability and how they're actually helping you drive the design of the other two dimensions that you mentioned, the AI side as well as the product lifecycle piece. Thank you.
So if I may add, so I'll actually bring a previous experience that I had, right? So prior to working at ANSYS, I worked developing drilling fluids type of digital twins for oil and gas. And there's a software, and there are design engineers that supposedly need to know how to design a fluid to perform that job. But as you know, oil and gas typically is an industry that is very cyclical and very, every other 5 years you get a downturn and boom, workforce is gone, right? So how do you create that next set of software that has embedded intelligence to minimize the inputs from humans and kind of, you minimize that subject matter expertise to a point that somebody that has a little bit less of that can still walk. They may not be able to run, but they can at least walk. So that's where I think also a lot of these tools are driving, is to make it easier for that non-expert can actually drive a design cycle, or at least move within a design cycle with less, needs for subject matter expertise that took 20 years to be developed.
Yeah, that's that institutional knowledge, right?
Exactly.
That transfer of order. Yeah, Danny.
I was just going to say a good use case. I didn't know this until I started working with Tesla. Tesla, in car design in general, the traditional way of designing a new car is to take a big hunk of clay and to carve it down to the design and have people walk around it and talk about it and re-sculpt it and do all this kind of thing. And the people that do the sculpting have a particular skill set. The people, like just maintaining that model is a whole, cost that needs to be accounted for. And so what we found is working with people like that to show them that there are tools that exist that can do it more efficiently in a more open manner. You can involve more people. You can streamline the workflow. You can get rid of a clay model. It's interesting to work with those people because this is the way it's always been done, and they don't want to change that. And so I think a lot of it is education. It's showing people the art of the possible and having conversations about, here's the way you do it now, here's the way that you could do it going forward. And the other big challenge there is that so many of those design processes, be it a car or fluids for oil and gas or drug development, like all of that is very, very specialized, and you get down to a very niche set of users. And so one of the big challenges I see in it is bringing it up to a level where there's some commonality across these different use cases that then might get specialized depending on I'm a car designer versus trying to discover a new drug. But again, I think technology plays a really important role of sort of creating a foundational capability that then can be specialized depending on what the different industries are.
Okay. And that's all the time we have, but I want to thank again our panelists who I think, brought a really fascinating look into this area and a very broad range of use cases and approaches. And so thank you all very much. I appreciate it. Thank you.
Ladies and gentlemen, please welcome Chief Innovation and Emerging Technologies Officer at the Orange County Government, Simone Babb.
Good morning, everyone. I hope everyone's excited about Michael's discussion around technology, digital twin, and the panelists that were just up here today. That's a very exciting topic for me. I've been doing transportation modeling for the past 2 decades, and I know we've got some technologists, researchers, education specialists, experts in this room. If you're any mathematicians, don't do any math to try to figure out my age. But for those of you who don't know me, my name is Simone Babb. I'm the Chief Innovation and Emerging Technologies Officer here with Orange County Government. I do want to, before I start, say a special thank you to our sponsors, the National Center for Simulation here at Table 1, Duke Energy as our host sponsors, and for everyone who's made today a huge success. My understanding is that we have about 200 plus or so in the room today, participants, all of you engaging today. So in my opinion, it's already a great success. So welcome, everybody. It is a great privilege to be in the presence of all of you here, like-minded individuals who share in that passion for topics related to digital transformation and everything immersive technologies. We've talked a lot today about digital transformation, digital twin technology, but as the day continues to advance, you'll hear a lot more. You'll hear a lot of simulation and modeling, AI, and the vast potential for this technology to really transform and enhance the way that we work, the way that we live, and the way that we play. We're so fortunate to be in the heart of Central Florida, in particular Orange County, because I also work for Orange County, which is home to one of the most prominent modeling, simulation, and training hubs globally. We're anchored by Team Orlando, the National Center for Simulation, our military services, all of which are in close proximity to our very own University of Central Florida, a world-class research institution. And I can talk more and more about Orange County and all the wonderful things it has to offer, but then you won't get a break. So I see today's summit as really an excellent opportunity for us to put our heads together, to network and to learn from each other, learn from the experts, because they're right here in the room today, and we're providing that opportunity for you today. One thing for sure is, and we've mentioned it even today during the panel discussion, is digital transformation is not something that we can really do alone. We need to put our heads together. We need to challenge each other and engage the experts, and they're right here today, so let's do it. There is significant value to collaboration, how others observe approaches to their own problems, their own projects. And you can find yourself by that very engagement, understanding strategies, your own strategies, coming up with your own techniques to breaking that challenge of how to move forward. Breaking down silos, listening to the industry's lessons learned, all key components. Today provides that critical value to each of us, especially if you're here, new into the industry in that exploratory phase. Today affords us that opportunity to understand the latest trends and to gain practical knowledge about everything digital transformation. So whether you're here to just learn, getting into the new business, into the new industry and space, if you're here to look for opportunities to expand any particular concept, drum up new business opportunities, or really if you're just here to get some food, coffee, and just network in general, you're actually in the right place. Whether you're in the sector of gaming, emergency management, healthcare, energy, defense, optics, photonics, manufacturing, etc., space, and transportation, the tools that we have here right now are really transforming the way we conduct, the way we do our business, enhancing a potential for business models, and how we actually look ahead and plan ahead for our projects moving forward. With sensor technology, AI, machine learning, 5G, learning algorithms, we can detect those patterns, those anomalies, and it's only going to make our lives better. And this is where I think that public-private partnerships become increasingly important as our resources, as the way we strategize and move forward together. Access to the real-time data is only going to continue to grow and evolve, and we have the power right now to simulate all kinds of behavior. We'll be able to test those new design concepts before they're built. That's the key, before they are built. You got the point. So there is significant value to what we're doing and talking about in this room today. That return on investment and efficiencies in processes will make this technology too big to ignore. So now I'll give you the real reason why I'm here. I have the privilege and the opportunity to now spotlight our sponsors and our vendor tables. I encourage you that if you haven't already had the chance to stop by as you were walking in and registering, to stop by our vendor booths. Get that engagement going. Once you can get me off the stage, you'll have that opportunity to go do that. Companies like Mass Virtual, Allen & Company, Applied Research, engineering and computer simulations have been in this digital space for quite a long time. And if you're interested in haptics, medical simulation, gaming platforms, talk to ECS. If you guys are in the room, if you don't mind standing so they can associate who you are in the room, and as they're going out and having coffee, everyone has an opportunity to network. Applied Research Associates, they present several of our modeling and simulation capabilities, including environment generation, serious game design and implementation, virtual and augmented reality, and high-fidelity battle effects. If you have an interest in the Air Force, aerospace, aviation, talk to Mass Virtual about how they are absolutely transforming. If you're in construction, surveying, unmanned systems, talk to Allen & Company. They're the ones with the drone at the first, when you first come in. Talk to them about their Purview 3D tools and how they've helped hundreds of construction sites around our city save money with digital transformation. They're engaged in LiDAR and reality capture for data. If you need to recruit the high-tech workforce of our future, talk to X-Force, Ingenium Staffing, and Career Source of Central Florida. We've also got Full Sail University and Orange Technical College in the room as well, so welcome. Intuitive is here with expertise in professional engineering, technical services, analytical support for innovative solutions. And if you really want to get further involved with what's going on in our region, we've also got Halldale, our Florida High-Tech Corridor, Central Florida Tech Grove, so engage them. All right, today is really an empowering opportunity for all of us. It's about information exchange, information consumption, and we have the time to do that. So with that, I'm giving you back 5 minutes to go do just that. We'll see everybody back here at 11:30. Thank you so much.
Hi, I'm Pam Neighbors. I'm the President and Chief Executive Officer for Career Source Central Florida. Our mission is to make talent the best for business and to connect Central Florida residents to good-paying careers. We fulfill our mission by focusing on the skills of individual residents and aligning them to the growing careers that are in Central Florida. In the past year, we have served over 43,000 individuals by providing them career services, which include resume review, employment assistance, job referral, and training scholarships. For businesses, we have served over 3,500 organizations by providing them screened candidates and also providing them opportunities to train individuals on the job. Career Source Central Florida is very proud to be part of this innovative and growing community in the Orlando region. I invite you to connect with us and learn about all of the services that we have for both residents and businesses in the Central Florida community.
In any business, You ride the line between numbers and people. It takes balance. CLA, CPAs, consultants, and wealth advisors will get you there.
I've learned a lot. Overall, yeah, I am happy. I think it was a good decision.
If you are very good at being a self-promoter and really passionate about what you're doing, the sky's the limit.
Full Sail University is where the next generation of creators are learning to build the future. It's where artists and creative thinkers unite with technologists and engineers. It's where you will get hands-on experience developing entertainment media and emerging technologies. If you have big ideas and even bigger dreams, start right here.
We all need someone to rely on whose mission is simple: to get him home safe, to sustain healthy communities, to help her reach the stars. When you need someone to rely on, it's Intuitive.
Hi, I'm Pam Neighbors. I'm the President and Chief Executive Officer for CareerSource Central Florida. Our mission is to make talent the best for business and to connect Central Florida residents to good-paying careers. We fulfill our mission by focusing on the skills of individual residents and aligning them to the growing careers that are in Central Florida. In the past year, we have served over 43,000 individuals by providing them career services, which include resume review, employment assistance, job referral, and training scholarships. For businesses, we have served over 3,500 organizations by providing them screened candidates and also providing them opportunities to train individuals on the job. CareerSource Central Florida is very proud to be part of this innovative and growing community in the Orlando region. I invite you to connect with us and learn about all of the services that we have for both residents and businesses in the Central Florida community.
Testing. Testing. 1, 2, 3. Testing. Should I bring it up a little bit?
CLA, CPAs, consultants, and wealth advisors. We'll get you there.
I've learned a lot. Overall, yeah, I am happy. I think it was a good decision.
If you are very good at being a self-promoter and really passionate about what you're doing, the sky's the limit.
Full Sail University is where the next generation of creators are learning to build the future. It's where artists and creative thinkers unite with technologists and engineers. It's where you will get hands-on experience developing entertainment media and emerging technologies. If you have big ideas and even bigger dreams, start right here.
Testing. We all need someone to rely on whose mission is simple: to get him home safe, to sustain healthy communities, to help her reach the stars. When you need someone to rely on, it's Intuitive.
Hi, I'm Pam Neighbors. I'm the President and Chief Executive Officer for CareerSource Central Florida. Our mission is to make talent the best for business and to connect Central Florida residents to good-paying careers. We fulfill our mission by focusing on the skills of individual residents and aligning them to the growing careers that are in Central Florida. In the past year, we have served over 43,000 individuals by providing them career services, which include resume review, employment assistance, job referral, and training scholarships. For businesses, we have served over 3,500 organizations by providing them screened candidates and also providing them opportunities to train individuals on the job. CareerSource Central Florida is very proud to be part of this innovative and growing community in the Orlando region. I invite you to connect with us and learn about all of the services that we have for both residents and businesses in the Central Florida community.
In any business, you ride the line between numbers and people. It takes balance. CLA, CPAs, consultants, and wealth advisors will get you there.
I've learned a lot. Overall, yeah, I am happy. I think it was a good decision.
If you are very good at being a self-promoter and really passionate about what you're doing, the sky's the limit.
Full Sail University is where the next generation of creators are learning to build the future. It's where artists and creative thinkers unite with technologists and engineers. It's where you will get hands-on experience developing entertainment media and emerging technologies. If you have big ideas and even bigger dreams, start right here.
We all need someone to rely on whose mission is simple: to get him home safe, to sustain healthy communities, to help her reach the stars. When you need someone to rely on, it's Intuitive.
Hi, I'm Pam Neighbors. I'm the President and Chief Executive Officer for CareerSource Central Florida. Our mission is to make talent the best for business and to connect Central Florida residents to good-paying careers. We fulfill our mission by focusing on the skills of individual residents and aligning them to the growing careers that are in Central Florida. In the past year, we have served over 43,000 individuals by providing them career services, which include resume review, employment assistance, job referral, and training scholarships. For businesses, we have served over 3,500 organizations by providing them screened candidates and also providing them opportunities to train individuals on the job. CareerSource Central Florida is very proud to be part of this innovative and growing community in the Orlando region. I invite you to connect with us and learn about all of the services that we have for both residents and businesses in the Central Florida community.
In any business, you ride the line between numbers and people. It takes balance. CLA, CPAs, consultants, and wealth advisors will get you there.
I've learned a lot. Overall, yeah, I am happy. I think it was a good decision.
If you are very good at being a self-promoter and really passionate about what you're doing, the sky's the limit.
Full Sail University is where the next generation of creators are learning to build the future. It's where artists and creative thinkers unite with technologists and engineers. It's where you will get hands-on experience developing entertainment media and emerging technologies. If you have big ideas and even bigger dreams, start right here.
We all need someone to rely on whose mission is simple: to get him home safe, to sustain healthy communities, to help her reach the stars. When you need someone to rely on, it's Intuitive.
Hi, I'm Pam Neighbors. I'm the President and Chief Executive Officer for CareerSource Central Florida. Our mission is to make talent the best for business and to connect Central Florida residents to good-paying careers. We fulfill our mission by focusing on the skills of individual residents and aligning them to the growing careers that are in Central Florida. In the past year, we have served over 43,000 individuals by providing them career services, which include resume review, employment assistance, job referral, and training scholarships. For businesses, we have served over 3,500 organizations by providing them screened candidates and also providing them opportunities to train individuals on the job. CareerSource Central Florida is very proud to be part of this innovative and growing community in the Orlando region. I invite you to connect with us and learn about all of the services that we have for both residents and businesses in the Central Florida community.
Ladies and gentlemen, please begin to find your seats. Our program will begin in 10 minutes. Thank you. Yep, walk-in music. Left side. Ladies and gentlemen, please begin to find your seats. Our program will begin in 5 minutes. Ladies and gentlemen, please begin to find your seats. Our program is about to begin. Ladies and gentlemen, please welcome back to the stage President, CEO, George Chados.
Welcome back. I hope everybody enjoyed their break, got to visit with all or most of our exhibitors. You can catch the rest next time. It's now time to move on to our second panel discussion, and it's my pleasure to introduce Dr. Grace Bohanec. Grace has a long career with both the Department of Defense, the Department of Energy, and to close out her career at the Department of Energy, she was actually Acting Secretary of Energy. While she was pursuing her defense career, she got her PhD at the University of Central Florida, and now we are fortunate enough to welcome her back as the director of the School for Modeling, Simulation, and Training and the Institute for Simulation and Training at UCF. So please give a big round of applause and welcome to Dr. Grace Bohanec.
Well, good morning. How's everybody doing? We had an exciting morning so far, and all of the speakers and the opportunity to get some of those nuggets is always important. So thank you, my panel, for joining. As George just mentioned, I have the fortunate opportunity to be the director of the School of Modeling, Simulation, and Training. And before I even, introduce the panel, and before I take a few minutes to kind of set up our conversation, I did want to thank the National Center for Simulation for their ongoing, tremendous, strong, deep partnership with the University of Central Florida. I'd like to thank Bev C. For her constant contribution to the university, but more important to this community in modeling and simulation. Thank you for chairing this and for offering me and the panel the opportunity to come and speak with you. I do want to set the stage a little bit because our panel is titled Increasing Value Through the Application of Digital Transformation. And because of my background, I always like to think of a couple things, and I think they will resonate with everyone and resonate with those who are going through this transformation. We all recognize kind of the constant change that's occurring, right? The appetite for technology. The fact of the matter, we talked about Internet of Things and the Internet alone, how we are all connected and how we, in some ways, are global and competitive and in a very highly complex environment. So this rapid disruption of innovation is occurring, and these new paradigms, that are around digital transformation and around digital twins and the use and the acceleration of their use, is really creating a competitive tool set and mindset. And that's where we see opportunity. That's where we see the value of the digital transformation. So we are so fortunate to have a wonderful panel today joining us who are going to give some perspectives, their perspectives. In the University of Central Florida, we've made a big commitment. I say we doubled down, right? We doubled down on an already excellent modeling and simulation faculty, expertise, educational program, and are increasing the opportunities around the application of digital twin technologies. We are working with Osceola County in growing the semiconductor industry by applying digital twin technologies. We are working with the Department of the Army and thinking about that next generation of training, of human digital training, a human avatar, a training, a digital twin of the person. And that's why we're so excited to be part of this conference. I'm so eager to hear more from my partners and my colleagues on stage. I hope you enjoy the panel. I hope it becomes a little interactive. Don't hesitate to raise your hand at the end, and hopefully we'll be able to offer many, many perspectives. So with that, I'm going to go ahead and we'll follow suit with what the first panel did. It worked very well. And so I will start out by introducing, I will start out with Ross Morelli. Ross is the manager at the Learning Innovation Center at JetBlue University. He has been in the aviation industry for over 16 years and is currently in this role at JetBlue Airways, and he uses a unique approach around revolutionizing learning experience at JetBlue University. So let me introduce you to Ross.
Thanks so much. Thank you. Thank you so much for that great introduction. So yes, my name's Ross Morello. I am the manager of Learning Innovation at JetBlue University. So we're actually headquartered just about 5 minutes away here on airport property. So it's a nice short drive this morning. I'm kind of in a unique and different space from a lot of the things that we've heard about earlier today. So I'm more on the user side. So less of the creation or sort of implementation, but looking more on the user side. So unfortunately, I don't have a unique product to offer you unless anyone is looking to visit one of JetBlue's very beautiful destinations. You can go to jetblue.com or, I'm just kidding. Not a sales pitch. We are at the airport anyway. But what we've really gotten to do, and what I get to do in my role, is I get to basically take something like a car. So, or an airplane, actually, is a better example. You can have an airplane around, but if you don't have a destination or a flight plan, then it's not really going to do anything for you. So what my team gets to do is take a look at a lot of these emerging technologies, these products, these concepts, figure out a way that we can actually create those learning objectives to tie in with those so that we can implement them into our programs and really foster a really unique training environment for things that could be a completely unsafe environment like air travel if they're not trained properly. So we're going to take a look at one of the simulators that we installed just a few years ago. It was one of our game-changing aircraft, our A220, so you can go ahead and start that video. Kind of show the timeline and some of the implementation of what that actual simulator does. So we started the contract in 2018 with one of our business partners called CAE. Construction began in 2019 in Montreal, and then they had to ship the entire simulator here in pieces. Basically looked like big refrigerator boxes, which arrived in May of 2020. And if you remember May of 2020, it was a bit of a confusing time because there were some things going on in the world. So our facility was actually shut down as we had to bring this full simulator in. So you're taking a look there at the actual jacks that the simulator is up on. Each one weighs about 800 pounds, so they have to pull that simulator up, put the jacks underneath, and then they provide all of the full motion, and as you can see on the right-hand side of the screen, one that's in actual operation, that simulated environment that our pilots get to go through so they can experience what they would have in the real world, again, in that safe training environment. What they're installing here is the visual, so it uses the Tropo 6000 visual screen. It's a giant Mylar screen that's using a vacuum system. Then as you can see here, the visuals are provided using a projection. And what's unique with this is the incredible high fidelity that this uses. That is actually footage from what the simulator does. It can replicate foggy environments, bad weather environments, but also lighting environments that are true to life. So they're installing the remainder of the hardware here, which will then go through about 2 weeks of testing because we want to make sure it's actually operating correctly. Because we're in a very highly regulated environment as well, something that's really important for implementations of new technologies is actual acceptance by all of the regulatory bodies, including the FAA, and anyone else that needs to have buy-in in that. What we did that was unique with this, because of COVID, we had to do it completely virtually. So just taking another one of those, what seems like simple technologies like a Teams call, being able to do that with the FAA inside a simulator to actually get sign off on one of our new devices. And then finally, we had that in installation and began our curriculum development and doing our actual training with that in the beginning of 2020. So that's just a look at probably one of the multiple dozens of simulators that we use, anything from as small as a iPad that has parts of an aircraft that they can interact with, moving up into like door trainers where they can actually interact with virtual slides and things like that, up to the full flight sim, which is probably what I would call our coolest almost Disney ride that we have there, since we were talking about Disney earlier. But it's really a unique approach that we like to take at JetBlue to train our new crew members, is what we call our employees, to the highest caliber and quality to make sure that safety and efficiency is really at the forefront. So thank you.
Thanks, Ross. So let me introduce our second panelist, Carly Hoffman. And Carly is a senior staff systems engineer at Lockheed Martin Enterprise Operations. And lo and behold, she is the lead for the corporate digital twin strategy implementation and the emphasis on how to establish digital twins in all of their enabling interoperability, reuse throughout their system design and lifecycle application approaches. So Carly, thank you for being here.
Thank you, Dr. Bochenek. I'm happy to be here to share some of my experiences with digital transformation. In my role working with our corporate engineering and technology office, again with that focus on our model-based enterprise and digital twins, my role really spreads across our entire business from that enterprise view. Lockheed Martin has 4 main business areas: the Missiles and Fire Control, Rotary and Mission Systems, Aeronautics, and Space. So you get that breadth of the land, sea, air, and space. And they all have their uniquenesses and their differences in missions. And really being able to mine those amazing organizations for their best practices and elevate those into a common framework that we can leverage as part of our transformation is part of the role that I have. I'm sure, just as the common theme we've heard from the first panel in here, modeling and simulation isn't something new to us. It's something that we've been doing for decades. When I first started my first program back in 1999, I was working on satellite operations. So going through launch and orbit insertion, we used STK to run those simulations, plan what ground stations we would use to collect the telemetry and send commands up to the satellites, understand how long we would have to be able to do those operations, and optimize that for a constellation of more than 30 satellites with just almost a dozen ground stations. So we would do that and monitor the health of those satellites. Today we're using some of the same tools, new tools. It's really in how we're using the tools that's changing, the automation that we're adding, the connectedness, the data. In the past, our data hasn't always been digitized. We still have cabinets of data on paper. So that is definitely a challenge that we're working to overcome in some of our legacy programs. But moving forward, we definitely have a new eye on what standards we're using to capture that data and make that data consumable downstream. And this is really just increasing as we discover new ways to leverage these tools and data to help inform our decisions. I have a quick video that I wanted to share from our space organization that highlights some of the different simulations and models that they're using to help enable our use cases for digital twins.
Your missions are complex, and we're applying new ways to deliver on those programs faster and with more value. By capitalizing Lockheed Martin's diverse portfolio of advanced technologies, we harness the power of our digital threads to create digital twins. Digital twin technology lets you simulate current and future platforms, optimizing your architecture and missions. Leveraging the digital twin synthetic environment allows users to execute what-if scenarios, test external interfaces, pressure test resiliency ConOps, war games, and simulate and display live coverage of battlespace assets. Digital Twin is also highly serviceable over the entire life cycle of your mission. Intelligence is built into the design using components and system artifacts from Lockheed Martin's model-based engineering catalog. Integrated with multidisciplinary analysis, intuitive system visualizations helps you move to production faster. Digital twin technologies drive and facilitate readiness reviews and automate pedigree report creation and delivery to programs. Artificial intelligence and machine learning algorithms are leveraged to eliminate escapements and streamline your system test campaigns, providing you with a quality product. By integrating your data from design through test and vehicle commanding with high-fidelity physics-based simulation, together with artificial intelligence and machine learning, the digital twin becomes a virtual replica of your physical assets, constellations, and fleets. This intelligence allows your system operators to refine mission architectures. It also validates resiliency CONOPS, diagnoses and resolves anomalous behavior, and significantly reduces your mission outages. We understand that the rapidly evolving demands of your missions have never been greater. That's why we embraced digital engineering, agile development, and open systems architecture to accelerate your progress. Digital twin is the crucial element that ties all your information together quickly and effectively to ensure your mission's success.
All right. Well, thank you. Thank you, Carly, for that introduction. And so let me introduce our third panelist, Alex Pazos. And Alex is a Senior Business Development Americas for NVIDIA. And he's bringing a perspective of 18 years of experience in computer vision, safety, security, IT space, and it goes on and on and on. The main point is really focusing on the applications of smart cities and spaces.
Perfect.
Thank you for being here, Alex.
Thank you. So yeah, today, basically, I'm going to focus on two topics, right? Well, these 5 minutes that we have. One is going to be touching on the digital twin, and the second one is the digital transformation piece, right? So what NVIDIA has created, we've actually created a platform called Omniverse. So Omniverse is a multi-module platform that allows multiple platforms. A lot of the speakers that were here previously actually are partners of NVIDIA. And what we've realized, if you don't have a collaboration platform, it gets really difficult for companies, agencies to collaborate across, multiple entities across the world and so on, right? So with Omniverse, the first thing is actually we've created something called the connector, right? So going actually to what the keynote was talking about, it's very focused on that, right? So the connector piece today integrates to over 30 different platforms. And then what we do is we actually use a USD file format, which is a universal screen description file format, to standardize that data across the board. So if I have, let's say, a collaborator in the US and I have another collaborator, in Israel, right? They can also be making changes in multiple systems, right? But they're using Omniverse as a centralized piece. So the idea with Omniverse is, let's say that in one agency, you're running Autodesk. In another one, you're running Epic, right? And you need to make changes from this singular platform. That's where you would leverage Omniverse, right? So let's say that you need to introduce some new lighting conditions, or you need to introduce some random errors potentially that's going to occur. You would do that in Omniverse, and all that will reflect in real time across these different platforms, right? So that's one of the value adds of Omniverse. And then what I'm going to show you, the video I am going to show you today is actually focused, of course, on simulation, right? So you're going to see, actually, we've partnered up with Mercedes-Benz. The new EV, the EQS vehicle, actually uses our NVIDIA Drive platform, which is an end-to-end platform. Today in California, we're the first level 3 licensed platform. So basically, this NVIDIA Drive platform actually allows Mercedes-Benz to introduce artifacts, errors, and like that, they can actually accelerate their entry into autonomous driving, right? If you can please play the video.
Did you want to talk? I
Yeah.
think we have
It's working.
Okay, you're working.
So I think something that was said also in the keynote is the ground truth, right? So you have all these IoT sensors. It could be RGB, it could be LiDAR, radar information. How do you feed this data? So this is where Omniverse comes into place, right? So here we're actually using a module inside Omniverse called Omniverse Replicator. So Replicator is our synthetic data generation engine that you could consume and absorb all these data sets that are coming in. In this case, it's LiDAR and radar, but it could be basically a point cloud. It could be any of these type of sensors, even computer vision data that can come in. So here you see the ground truth. The other thing I think that was talked in the previous panel is how do you measure ROI? And one of the things that we've seen is when we get in front of cities, hey, what do you really want to use this digital twin for, right? And what's the immediate ROI? So one of the things that we've realized is, hey, if you don't maintain real-time data being ingested into the digital twin, in a day and a half or in seconds, that digital twin is already old, right? So that's where you have to continuously put in data into the digital twin. So that's what we're doing with this platform as well, right? So again, there's another module that's called Renderer. That's actually the one that you get, pixel accurate and physically accurate data that you can see here. And then here you're actually seeing the domain randomization that we're inserting errors into the scene. So if the vehicle's driving through the parking lot, right, we can immediately introduce pedestrians, another vehicle, a cart, potentially if it's a supermarket parking lot. Next video. I know we're running out of time, but. So this is actually ISAC-SIM, which is another extension of Omniverse. So this one, basically synthetic data for training for robots. So whenever you have a chance, if you search NVIDIA Omniverse and BMW, we also partner up with BMW to optimize their entire manufacturing plant. So Omniverse is being deployed across all their manufacturing plants to actually train their robots in the factory floor. And that has actually reduced over 30%, and actually physically, modifying the robot or, positioning a new worker that's going to work here, you could simulate all that. And, they can actually test and simulate how everything's going to work and be optimized, right, once you test this in the simulation environment. And the last video is actually the digital transformation piece.
Take your time. We can,
okay.
Yeah.
So the digital transformation piece, why is critical? And this is actually my space, right, which is computer vision. Right, we were talking about machine learning, so this is critical, right? Because the end goal, right, is to optimize. For example, these are partners, right? We're very partner-driven, so these are partners that do like curbside management, right? So this data, at the end of the day, is going to end up potentially in the digital twin to optimize parking management, right? This is another partner that does LiDAR technology, and Velodyne or Blue City. They actually are detecting with LiDAR near-miss detection, post-encroachment times, and time to collision, right, which is critical, again, to simulate and to get to that level 5 autonomous driving. This is another partner called Saya. They fully optimize the apron of an airport, right? So we were talking about the airport of the future, right? Critical solutions for that. And these are other partners that you're going to see there that basically you can optimize from a retail environment all the way to the manufacturing environment, all the way to a surgery potentially, right? And that's how these partners are leveraging our technology. The last thing I'll mention is, a lot of people see NVIDIA as a hardware company. We've actually transitioned fully to a software company, right? So yes, the software, of course, is going to have to leverage the hardware, right? But we've totally transitioned to a software company. So what we bring, to the table is, hey, if you are trying to enter the space, we accelerate that entry for you as a partner. So we have a ton of pre-trained models, right, that are accessible at no cost, right? You can enter this space immediately. I think the keynote speaker was talking about that. Hey, how do you accelerate that, right? Potentially using large language models. Also, we have a stack around that. So it depends what the use case is, but we have different solution stacks that could do that, can help into that digital transformation. And again, these are just other examples you see for inspection of fruits to see the growth process, right? And they're leveraging our solutions, our pre-trained models, and of course our edge components, devices to process that, those models actually. Yep, and that's basically
Thanks,
it.
Alex.
Thank you.
Thanks for the information. So again, our panel is really designed around a conversation around value and a conversation around how are we moving forward, right? A lot of discussion this morning in regards to the opportunities of tools and the use of those tools. And in all of our cases, right, we're thinking in that direction of the use of the tools and the integration and interoperability. But I want to bring it up, start at a very high level potentially, because we talk about digital transformation, and like digital twins has a lot of different definitions. So I thought maybe just hearing from each of you, what does it mean in your organization? How are you personally, what's your role in the organization as they go through the digital transformation and the use of these digital twin kind of technologies and tools? So I can start with you.
Of course. So I think it's very important, and it's something that's obviously at the forefront of everyday life, basically. Every day something's changing, the new phone's coming out, or it's the same thing with the airline, as you can imagine, that once something is sort of in place, then a new technology comes out, and we're trying to find a way to really implement that. Where it comes back, especially in kind of my role, I work very close. We have a completely in-house learning design team. All of our crew members go through actually the facility here that go through their training. So it's almost having to work 2 steps ahead because it's not just when something new comes out that it's implemented. We have to reverse our way backward and look at how we can actually engineer that training, make sure that training is approved and in place in time to actually implement this change. So it's really important for us to be almost have foresight into kind of what's coming and almost take chances, if you will, and really follow through with some things that may seem like a trend, may not be universally adopted, but something where we can actually explore the path through that. To go back to our unofficial theme of Iron Man today, which is so appropriate, I kind of look at it almost in the opposite way that we've discussed it. So if you think of those very grandiose scenes that you see in Iron Man, if they're flying through the air or doing things like that, they create such a reaction and are so satisfying when you see them on the movie screen. And then when you see the picture next to it of how they filmed that, it's someone in a giant room like this with probably just this blue curtain, and they're dangling from a wire, and there's green men like moving them around. And it's so jarring because it takes sort of that experience or almost effectiveness out of what's actually happening in that. So I think what we try to do is almost do the opposite, where we're trying to take what is that fantastical thing, whether it's flying in an aircraft, whether it's experiencing on the ramp, or things like Alex was talking about, really utilizing safety in the apron of the airport, and bringing those into a safe or simple environment, but in a very realistic and high fidelity way. So there's quite a focus on that in order to provide the most effective way to have someone experience something that they couldn't experience in real life without putting either someone or something in danger. So it's very important. I used to always say if there was a problem in the air, you can't just pull over and fix it. So need to be prepared.
Very much true. Let's hope that doesn't happen in the future, right? Carly, would you like to comment on that?
Yeah, definitely. So even before I joined our transformation organization, I've been part of digital transformation for at least the last 15 years. Even though I might not have realized it and we weren't really talking about it back then, there were pockets of change, unique implementations happening on small projects and programs, but we weren't always aware of what was happening in other areas of the company. So a lot of this really, I think we're at a tipping point now where we're seeing that buy-in from the workforce and the management. Even, I mean, over the last 8 years or so, as a company, our vision for that transformation has really made a big change. We're not just looking at those individual capabilities or individual domains. We're looking at more of that integrated approach to transformation. We have a champion now in our executive management. And we're not just looking at transforming products or engineering tools. We're looking at the business as a whole. We're looking at how do we transform our financial systems, our HR systems, our procurement, our training, human resources. Nothing's off limits. All the processes and systems are being challenged at this point. I'd mentioned that Lockheed's made up of four major business units. They all have histories of different acquisitions and programs and different customers. And that's kind of shaped where they are today, how they operate, their structure. And we're trying to streamline that, get a little bit more efficient so we can leverage that scale of our business. So we are definitely looking to make learn as much as we can from the unique position that they're each in, but then again, learn from them. And in the past, that's kind of been a justification for their stronghold. They do have unique missions and they do have unique customers, but now we're kind of in this new environment where our customers on board with this transformation. They see the need, the value, and in a lot of cases, they're starting to drive and demand that we operate in these ways. And it's really created a big opportunity for us to make big changes in how we operate across our corporation. So putting a critical eye on those differences that we have, driving standardization where it can make significant impacts for our company, and really focusing on what our customers have said that they need. They need speed and agility now. They need to be able to adapt to that changing battle space, and we need to be able to support them in how they do that. And in a lot of cases, that's more important than having the coolest gadget out in the field. And personally, and I think a lot of people within my company probably find that a hard pill to swallow. We're used to making that coolest fighter jet or the biggest missile, and now it's like, well, learn from what you've done in the past, adapt that to be more effective now and as fast as you can, and leverage that digital space and that connected information. So that is where we are focusing to try to leverage our data that we have, make it consumable by the users, and really look at the discriminating analytics capabilities that we have.
So you make a couple great points, and I think we heard a little bit of that earlier too, right? I mean, there's a demand. There's a demand by, individual people, right, that have to use these kind of systems or who want to be involved in the decision, to customers or clients or governments. And so that demand is also, driving this and really making us really think about the speed and the agility and the flexibility that kind of digital twin and this digital transformation offers. Just wanted to ask, Alex, would you like to, just from your own viewpoint and the experiences you've had, what do you think about this digital transformation?
Yeah, I think it's real and it's happening. The approach that we take at NVIDIA, right, it's more of a kind of a thought leadership approach. So when we do engage, let's say, with end customers or partners, right, we try to drive jointly their AI journey, right? It could be AI journey, it could be the digital transformation journey. Also, as you saw, I lead smart cities and spaces, so we're also verticalized, right? So we have subject matter experts in healthcare, in smart cities and spaces, manufacturing. So it also depends on what's the use case. I think that was another point of conversation in the previous panel, right? What's the workload? What's the use case? What are they trying to solve, right? And that's another, I think, a huge value out of NVIDIA. When we get into a conversation with a partner or a customer, we're not trying to sell you anything. We're actually going more at it as a consultative approach to solve that problem, right? And then from there, it's going to drive the sale, right? Because they see it more as, hey, this is a partner, and they're just not trying to sell me something, right? And I think that has worked immensely. I've been at NVIDIA for almost 2 years. Also, our CEO, right, Jensen, he drives a culture of, hey, test it. If you fail, doesn't matter. Let's pivot, readjust the recipe, and let's try it again, right? And that's how we've been very successful in some of these industries, right? Like, there's actually a video, he just did an interview with, I don't remember the channel right now, but it is on YouTube. And he talked about, in this interview, they talk about, hey, NVIDIA got into the cell phone industry many years ago. And we pivoted quick because we saw that was not it shouldn't be our focus, right? We did the same thing when infotainment in the vehicle became a hot topic, right? We got into that space. We saw it was not a good, investment for us. So we pivot. Guess what? Now we're dominating the autonomous driving space, right? So the whole culture is pivot quick, make sure that you could, provide results, right? And then at the end of the day, bring added value to the partner or customer that you're dealing with, right? And I think that from the personal side, just to answer that, I think in every company I've worked for, I've always kind of had that approach with customers, partners. And if you do, then you become a trusted partner, right? And not just someone that's trying to sell something, right? But yeah.
Well, you know, when you say fail often,
yeah,
but fail it in simulation,
yeah,
and you do as many iterations as you can to get to the point of, you know, what is that tolerance? What can you accept?
Exactly.
And so a lot of this has to do with, you know, changing of culture. I think we heard that earlier today, and building a culture around being model-centric, right? Being data-centric and using them appropriately. So I was just curious, thoughts about culture real quickly before we move to a different topic, but just the idea of culture and how are you seeing that culture change over time in your organizations? Carly, maybe we'll start with you, if you're
Sure.
up for it.
Yeah, I think we've definitely seen a bigger appetite for change through all levels of the company. Definitely from the new blood coming in, they want it now. They're ready. They're wondering why we're not there yet. There's still some resistance, of course. I think that'll probably be the case for a while. But definitely there is a culture shift, and it is important to accepting this transformation. And being able to actually foster that change in culture, helping those that are struggling with it to understand why we're doing what the value to them is. I heard that before. We're not replacing the engineer. We're trying to free them up to be able to do the hard stuff. Give them the tools to make it easy. Push that easy button. Sorry if I'm diverting a little bit here, but at the same time, there was that conversation about developing that design engineer. We don't want to lose that. We still need those people. Even when you have the easy button, we don't want to become too reliant on the technology. You still need the people that know how to build the technology, operate, how the technology operates. So having that balance of being able to generate that workforce and that culture going forward to make that happen.
So it's an important topic. I don't know if anyone wants a comment, but I would also ask, you know, so here I am, you know, in the university, thinking about the next generation of workforce. You know, how do we create the agility, not just in the use of tools, but the application and decision of using those kind of technologies? You maybe want to add some thoughts about, you know, what do we need to think about as a future workforce in this new culture?
I think something we were talking about earlier, and it's a kind of silly example, but I was at a restaurant not too long ago, and I just caught the eye of watching all of the mobile orders as people came through and picked them up. Mm-hmm. And it made me sit and think that it was so interesting that this is now such a norm and something that is almost more prevalent than going out and sitting and eating at restaurants or using drive-thru or whichever way you would actually do it in a more traditional sense. But there was no technological breakthrough or something that really made this possible. It was really a cultural shift, and it was through necessity that this needed to happen. So I think in looking toward the future, it's very much the same way that if there's that focus and really push to continue the drive forward, that you can continue to do that in using the tools that are actually potentially already available, but then continuing to develop on those and expanding on those as well.
Good points. I mean, when you think about that, I mean, we're all doing that, right? Yeah. We're all doing. We just find it more convenient, right? Mm-hmm. Alex, you wanna? Or
yeah, I mean, I'll add something. I think it's like you mentioned, right? I think it's a progressive learning, and I'll give the example of cars. Maybe 10 years ago, right? So you will get in a car and you have cruise control, right? You're like, oh. Cruise control, what does this do? So you'll turn it on. Then 5 years down the line, then now you have lane keep assist, right? So you can maintain the lane. So little by little, the industry has been kind of educating us, right, progressively, so we can start feeling more comfortable with technology. Now there's cars that, level 1, 2 of autonomous driving, right? But it's been a progressive shift, I think, to get there. So I think it's the same thing with new technology. I just mentioned what our CEO said in our last GPU Tech conference that we have, right? He said that ChatGPT or large language models is the iPhone moment, right? So when Steve Jobs got up there with the iPhone, it was the iPhone moment. So LLM, it's the same thing, right? It's now people have been little by little getting accustomed. It started with intelligent video analytics, then it shifted to machine learning, then computer vision. And now, we're adding that layer of more capability on top of that. But at the end of the day, it's not only to optimize your operation, but it's also to optimize the human, right? So if we use that technology accordingly, we're going to be more optimized, I think.
That's why I think this community, and all of us, right? I mean, academia, the universities, industry, and our government is just very serious about how we should move forward with it. You can use the word digital transformation, but the use of these technologies that can enable innovation in a different way that we could never even imagine. So it opens up so many different possibilities. One of the things I would like to know, maybe I'll start with you, Alex, is you've seen and you've applied a lot of these technologies over the years. What do you see as some of the challenges right today? What are those challenges?
I think the biggest thing right now is let's talk about the SLED space, right? Like public sector or state and local, right? It's a lot of, maybe it could be workforce development, or it could be like, there's so much grants out there, right, to tap into, but there's not enough potentially grant writers, right, to grab those grants and accelerate the effort of technology, right, into cities. So I think the biggest challenge, or something that could fix that, and we're starting to see it little by little in pockets in the U.S., is public-private partnerships. I think that's something that really needs to happen to accelerate cities to implement technology, right? Because then you kind of decrease sometimes the bureaucracy, right, that's happening. And I think someone else mentioned that in the previous panel or in the keynote, right? That when there's too much politics, then it just takes so long for you to transform, right? And I think public-private partnerships will help that. And that's what we're starting to see that. I mean, we're starting to see that, and also the biggest pain point is proving the ROI, right? If you cannot prove that this is going to give an immediate return on investment, it's going to be very difficult. Like right now, right? There's what is it? The U.S. DOT, I think, just announced $160 million, in funding, and $2.3 billion in extra funding for ITS workloads, for Vision Zero, right? To decrease pedestrian fatalities, detect near misses. But we're not tapping into that quick. Like cities are not doing that quick, right? So how do we accelerate that effort? I think potentially, my opinion, right? Public-private partnerships are critical for that.
Well, I mean, you make a wonderful point, right? If the process and the idea can't come together very quickly, you miss an opportunity. Yeah. And I know, just from my federal background, they're really looking at different ways, and that's why, when we think about how do we move forward, it really is around this kind of partnership opportunities. But you have to be postured, you have to be ready, and you have to have those kind of concepts. And I think that's where we're all leaning today, I think, in all of the partnerships that we're talking about. Carly, would you like to, otherwise we'll jump to different questions, but if you have some thoughts you might want to share.
I'm going to touch back to one of the things that Dr. Roper said this morning about the physics-based models. I'd say, at least in our space, when we're on the cutting edge of design, that's one of our big challenges. Everybody knows the famous NASA quote, "Failure is not an option." And that has been ingrained in our culture for decades. Failure is not an option. When we put hardware out there, it has to work right. And in many cases, it has to work right the first time. We don't even want to see failures in test. When we see a failure in test, it's not acceptable. Right. So how do we learn in that virtual space when we haven't yet collected the data when we're pushing the edge of the envelope? So finding that balance, being able to change the culture, to be able to collect that information, build those physics models, gain the trust, understand the risks, and then be able to really utilize them to move forward faster.
Yeah, we got some tough challenges to face with some of those things. But when you think about it, the ability to adjust and adapt, right? And we all come from an era, right, where failure wasn't an option, right? Or at least it triggered a negative response. And I think with this digital transformation, it's changing that culture. And I think what you're seeing in the university systems is building that workforce, that next generation of leaders, who that's going to be natural. They don't even think about the idea of not failing. They think about failing often. So good points.
I love being here on the Space Coast, seeing SpaceX when they tried to land those boosters so many times, and then just going back and doing it again. Because in my past career, if you failed twice, the program was probably dead.
And that's,
So
you know, that's a
it's nice to
challenge
see that
through the organizations, right? Not just in our own organizations, but in the organizations we're all doing this work for, right? And so this is a huge shift of thinking across government and industry alike. Would you like to make any comment on that?
I would say another challenge is just kind of getting buy-in on that return on investment. I think a lot of times, especially the closer that we are to either the technologies or the products, like, we get it. Like, I understand how this works. You can give me your elevator pitch and it's like, cool, I know exactly how I'm going to implement that. I know exactly what the end case is going to look like. Then in doing that in a presentation, it might be really difficult for, you know, leadership or the person that has that checkbook and the pen in front of them to say, this is what you're going to get out of this and it's going to be worth it. So I think really being able to get that leadership buy-in, being able to share the vision and really the expectation of what we're trying to do, not only would really foster us to continue to move forward and implement a lot of these great things, but also just, again, making that culture bigger and really continuing to kind of have people that join in, which I think is really, really important.
So I will deviate a little from our earlier conversation, but it seems to me, you know, data is king. We keep saying that, right? Data is king. There's a lot of social and privacy issues when you think about that, and you know, I'm confident we'll all figure that out. We'll solve it. My question would be more around challenges around when you're trying to integrate so many different models about IP and what that might look like when you start thinking about the metaverse and the concepts that were discussed even this morning. Do you see that as something we can resolve? Have you been thinking about this?
I can start that if you want. I'll definitely say that's not something we have an answer for. It's something that we talk about quite a lot. And as an integrator of products, we owe that to our vendors. We have to protect their data as well as ours. And not only just intellectual property classification of data, understanding how to put those controls in place, how to combine both from a cyber perspective and then just the categorization of data. How do we limit the access? How do we provide the capabilities while still protecting that IP that is generating that benefit? And it is talked about quite a bit. We've heard from our customer that they want to own everything. We know that's not realistic, so we are always in negotiations, hoping we don't trip up in our contracts as we're starting to let those out and that we don't unintentionally sell out any of our vendors and their data. But it's things we're working with some of our tool vendors as well. How do we ingrain that in the tool so that we can easily mark what can be shared and what can't be shared, or what needs to be obscured versus what can just easily be provided.
And I think it's a challenge for all of us. And I mean, even the first panel, Michael Chance talked about, you know, we just need the innies and the outies of that box. We need to know how the box works and have trust in what's inside that model. But it's very complicated. Did either of you want to, or have any thoughts on that?
Yeah. I mean, the NVIDIA's approach, it's a little bit different. So we actually, all the pre-trained models that we've developed, or let's say the IP, they're accessible. I mean, once you sign up at NVIDIA.com, and we have something called NVIDIA GPU Cloud, all our pre-trained models are there. Once you do download them, right, there's actually no royalty fees, nothing, right? Again, I think someone said something critical earlier, right? Democratizing AI. And this is the way to do it. You have to provide all these tools and also training. So we also have a huge focus. We have a full program called the Deep Learning Institute, right? So this is how we drive that workforce development. So let's say that, I don't know, you're focusing on a particular model for natural language processing, right? So you download our stack and it's yours, right? Now, if you require, this is how we monetize, right? Let's say that model, if you require enterprise service level support, then yeah, there is a licensing fee. But if you don't, you're free to use these pre-trained models, right? And again, how do we democratize and more companies and more startups to leverage these solution stacks and bring more value to their customers, right? So that's the approach that we're taking today.
Yeah, I think that, you know, when we, as we're thinking about at the broadest level of metaverse, you know, it'll be a lot of trial and error, right? What works and what converges and what doesn't converge. You know, so far we've had a lot of conversations around, you know, return on investment, you know, focusing on what you're trying to solve, right? Applying things in a very purposeful way and understanding, you know, what the end game is, right, to get to that return on investment. So I wanted to at least spend a few minutes and open it up to the audience. Hopefully you have some questions. We got a great panel with a lot of experience in applying and living through the applications of this digital engineering and digital transformation.
5 minutes.
Oh, is that what that is? I'm from the university. We look at that, we keep talking. Anyways, I hopefully we have some questions. I mean, we wanted to have a conversation really around the value again and the challenges, right? And how we're kind of navigating through that. Anyone want to take a stab? Go on, put us on the spot.
Hey, thank you for doing this panel, Grace. Thank you. So, Neil with NCS. I just wanted to pull a thread on something Alex was saying because I think he was really close on something. So, obviously, many of us know in this room that a lot of this started in DOD, but now you can see how it's accelerating to every other industry, tourism, agriculture. We've seen it all today, which is really exciting. And so this is going to be a really big deal, and it's accelerating. But there's another thing, Grace, that I think could potentially come out of this, and that is the barrier to entry now into our business. It used to be tens of thousands of dollars you had to invest, hundreds of thousands of dollars in equipment. Today, people with a second, third generation HMD and a free Unity or Unreal engine can start applying for SBIRs across the government, small innovative research grants, which is exactly what Alex was talking about. And so that gives people an opportunity that haven't been in our business before. Minority-owned businesses, women-owned businesses, veteran-owned businesses. So there's a big opportunity now, not only to do digital transformation, but to transfer the way the folks that are coming into our industry and change communities. So how can we not miss this opportunity? How can we partner with our local governments and put in policy so that we can get our students and our teachers educated on what's about to happen and get a new generation, a diverse generation, into our business? So that's my question. It's a tough one, but that's my question.
It's a tough one, but you know, let me say that I think the federal government is all in, right? All in recognizing that digital engineering, digital twins, the digital transformation is key to our ultimate competitiveness globally. And so we're seeing even in the university, which I find fascinating, I didn't, you know, that even the Department of Education has recognized the skill sets needed in modeling and simulation and have put out tremendous amount of opportunities, educational grant opportunities to increase the modeling and simulation workforce, right? The education, whether that's K through 12, the things that you're doing with NCS,
or the things that we're doing in, in undergraduate and graduate programs. So one thing is I see that. I also see that no matter what department in the federal government, they're really thinking about the regional aspects. And so this kind of conversation and this meeting where we can come together and bring talent quickly is going to be important. Now the how is maybe a little bit more challenging, and I think some of the key is the public-private partnerships. But I don't know if my panel has any thoughts on maybe on how we navigate some of those things.
No, I also think, involving universities is critical. Like, for example, I think if I'm not incorrect, is UCF. UCF, has an NVIDIA supercomputer, right? Because one of our founders is actually an alumni from there. So that's a way for universities also. And I believe UCF works very closely with Florida DOT, right, to accelerate some of those technologies they want to implement, from Vision Zero all the way to they're creating the closed loop system, right? I think here also I think it's in Orlando or maybe a little bit more up north, to do closed loop automation testing, right, for autonomous driving. And again, if universities are involved, same thing with in Texas, right? In Texas, TAMU, right, also is driving innovation with the DOTs, and they're leveraging their resources to also accelerate the entry into this space. Another one that I can tell you is, because our founder, Jensen, right, the CEO, Ohio State, same thing. So we have a huge focus. NVIDIA, that's the first focus. Hey, how do we get, from the university level, right, how do we get all these students trained in this type of technology, right? If they're doing those programs, of course, right? But we have also a supercomputer in Ohio State. So I think that could help also accelerate this effort.
Well, access to those capabilities and early exposure often leads to the kind of quicker adoption. Yeah. So some of that, Neil, I think we have to explore it, right? We have to be prepared, and we should converge and think about different ways. Because sometimes I think, universities can lead certain efforts. Sometimes industry has to lead. Sometimes, maybe government has to lead. But if the partnerships are there, then we all lead together, right? And I think that's what we're trying to do in the university. We're really trying to focus on, pivoting to really application-oriented. How do we work with NVIDIA? How do we work with Lockheed? How do we work with JetBlue? How do we bring not just the educational component, but the research to help drive things and accelerate our abilities? Anybody else have a question? Oh. Gentleman over here to the right.
Thank you. Testing, 1, 2, 3. I wanted to put a question for the panelists. I am young enough and fortunate enough to have been part of a modeling and simulation pilot while I was a sophomore in high school, and I graduated with certification in CAD and things like that. One thing that I've noticed as I've grown up in life is that while technology is moving faster and faster, failure may not be an option, but at the same time, failure sometimes is inevitable. And oftentimes you'll see news articles, especially with, for example, Tesla, where sometimes, yes, the product is of a good enough quality to release to the public, but sometimes accidents do happen. My question for the panelists is, what measures are being taken in your respective companies to minimize these faults and failures and to prevent accidents and tragedies once your products are released?
Yeah, I can start. So one of the things that's, especially in the training world, is unique is a lot of it's focused, once you get past the actual hardware that you're using, whether it's a simulator or an actual airplane, things like that, you really get the human factor built into it. The human factor is really hard when you're looking from an evaluation standpoint because it's something that's very subjective. So if they move too slow, they move too fast, you're not really getting a lot of feedback there. So we're really implementing a lot of technologies, whether it's through virtual reality, eye tracking, data tracking, things like that, even just with the hardware, to make sure that we can actually use that to really implement a much safer environment in our sort of training environment. So thank you.
Okay, if we're not cut off on time here. Yeah, I mean, there's layers of safety, of course, especially when you're dealing with weapon systems. When we're talking about digital transformation, and that failure is not an option, we're still working on that trust in the data, that trust in the models, making sure that we have fully characterized the risk before we get to that point where we're putting something out there, even just from a testing perspective. If we're going to put a test pilot in a plane, we need to know that that plane is going to fly. So, I mean, we have requirements and safeguards and quality and entire organizations built around checks and balances for safety. And that's not going to go away anytime soon. But we are still working to increase that confidence in the models and simulation to help speed us up in that. And then, of course, just like JetBlue, training. All of our products come with training. Some of it that we develop here locally in Orlando, the training and simulators similar to the ones that Russ showed.
Well, trust and confidence become really important, right? Especially when you're deploying things that require a level of safety. Alex?
Yeah, I would just add, it depends, I think, to answer that question, it also depends on the industry. So, for example, for manufacturing and transportation, NVIDIA, and this is more component level, hardware level, we actually have implemented something called IGX. So it actually has an extra layer of what we call functional safety, right? So that specialty chip, let's say, what it's going to do, it's going to prevent, right? So let's say that for some reason the compute chip fails. You have this functional safety chip, right, that is actually going to assure that if there is a man in the loop, right, or a person in the loop doing the process, that the machine doesn't hurt, that person, right? So automatically, that functional safety capability is going to stop the machine from hurting that person. On the other side, too, for right now, it's LLM, right? It's a huge topic, right? Generative AI. So and this you could search it, we announced it recently. It's called NVIDIA Guardrails. So NVIDIA Guardrails is actually to prevent from using large language models and generative AI in the incorrect way, right? So that's why we implemented NVIDIA Guardrails. So these are ways that we're, adding these layers of capabilities and actually safety nets, right? To assure that, hey, either the machine doesn't hurt a human, or when, let's say, someone asks a question, potentially Guardrail detects that in real time and stops that process, right? So that's kind of ways that we're doing it.
So hopefully we kind of answered that, right? What I'm hearing is, safety is a #1 priority in all of the, in your organizations and into how we're actually deploying and using these digital technologies as we go forward. Well, I wanted to give an opportunity for us to thank Ross, Carly, and Alex for joining the panel. Thank you very much. We really enjoyed hearing from you. I think many of us will be around, so if you have any questions, please don't hesitate. Thank you for attending our panel.
It's time for lunch, and I have some very specific instructions, so please don't get up and leave. Our Florida Simulation Summit ambassadors will be assisting and directing everyone through the lunch buffet and back into the ballroom. Please exit via the side doors on your right if you're sitting on the right side, and on your left if you're sitting on the left side. We also have another buffet line accessible straight out ahead in the hallway. Please enjoy this delicious lunch and remember to visit the vendor and exhibit tables. We will resume the program at 1:30.
CLA, CPAs, consultants, and wealth advisors. We'll get you there.
I've learned a lot. Overall, yeah, I am happy. I think it was a good decision.
If you are very good at being a self-promoter and really passionate about what you're doing, the sky's the limit.
Full Sail University is where the next generation of creators are learning to build the future. It's where artists and creative thinkers unite with technologists and engineers. It's where you will get hands-on experience developing entertainment media and emerging technologies. If you have big ideas and even bigger dreams, start right here.
We all need someone to rely on whose mission is simple: to get him home safe, to sustain healthy communities, to help her reach the stars. When you need someone to rely on, it's Intuitive.
Hi, I'm Pam Neighbors. I'm the President and Chief Executive Officer for CareerSource Central Florida. Our mission is to make talent the best for business and to connect Central Florida residents to good-paying careers. We fulfill our mission by focusing on the skills of individual residents and aligning them to the growing careers that are in Central Florida. In the past year, we have served over 43,000 individuals by providing them career services, which include resume review, employment assistance, job referral, and training scholarships. For businesses, we have served over 3,500 organizations by providing them screened candidates and also providing them opportunities to train individuals on the job. CareerSource Central Florida is very proud to be part of this innovative and growing community in the Orlando region. I invite you to connect with us and learn about all of the services that we have for both residents and businesses in the Central Florida community.
In any business, you ride the line between numbers and people. It takes balance. CLA, CPAs, consultants, and wealth advisors will get you there.
Yes, we are good.
I've learned a lot. Overall, yeah, I am happy. I think it was a good decision.
If you are very good at being a self-promoter and really passionate about what you're doing, the sky's the limit.
Full Sail University is where the next generation of creators are learning to build the future. It's where artists and creative thinkers unite with technologists and engineers. It's where you will get hands-on experience developing entertainment media and emerging technologies. If you have big ideas and even bigger dreams, start right here.
We all need someone to rely on whose mission is simple: to get him home safe, to sustain healthy communities, to help her reach the stars. When you need someone to rely on, it's Intuitive.
Hi, I'm Pam Neighbors. I'm the President and Chief Executive Officer for CareerSource Central Florida. Our mission is to make talent the best for business and to connect Central Florida residents to good-paying careers. We fulfill our mission by focusing on the skills of individual residents and aligning them to the growing careers that are in Central Florida. In the past year, we have served over 43,000 individuals by providing them career services, which include resume review, employment assistance, job referral, and training scholarships. For businesses, we have served over 3,500 organizations by providing them screened candidates and also providing them opportunities to train individuals on the job. CareerSource Central Florida is very proud to be part of this innovative and growing community in the Orlando region. I invite you to connect with us and learn about all of the services that we have for both residents and businesses in the Central Florida community.
In any business, you ride the line between numbers and people. It takes balance. CLA, CPAs, consultants, and wealth advisors will get you there.
I've learned a lot. Overall, yeah, I am happy. I think it was a good decision.
If you are very good at being a self-promoter and really passionate about what you're doing, the sky's the limit.
Full Sail University is where the next generation of creators are learning to build the future. It's where artists and creative thinkers unite with technologists and engineers. It's where you will get hands-on experience developing entertainment media and emerging technologies. If you have big ideas and even bigger dreams, start right here.
We all need someone to rely on whose mission is simple: to get him home safe, to sustain healthy communities, to help her reach the stars. When you need someone to rely on, it's Intuitive.
Hi, I'm Pam Neighbors. I'm the President and Chief Executive Officer for CareerSource Central Florida. Our mission is to make talent the best for business and to connect Central Florida residents to good-paying careers. We fulfill our mission by focusing on the skills of individual residents and aligning them to the growing careers that are in Central Florida. In the past year, we have served over 43,000 individuals by providing them career services, which include resume review, employment assistance, job referral, and training scholarships. For businesses, we have served over 3,500 organizations by providing them screened candidates and also providing them opportunities to train individuals on the job. CareerSource Central Florida is very proud to be part of this innovative and growing community in the Orlando region. I invite you to connect with us and learn about all of the services that we have for both residents and businesses in the Central Florida community.
In any business, you ride the line between numbers and people. It takes balance. CLA, CPAs, consultants, and wealth advisors will get you there.
I've learned a lot. Overall, yeah, I am happy. I think it was a good decision.
If you are very good at being a self-promoter and really passionate about what you're doing, the sky's the limit.
Full Sail University is where the next generation of creators are. It's where artists and creative thinkers unite with technologists and engineers. It's where you will get hands-on experience developing entertainment media and emerging technologies. If you have big ideas and even bigger dreams, start right here.
We all need someone to rely on whose mission is simple: to get him home safe, to sustain healthy communities, to help her reach the stars. When you need someone to rely on, it's Intuitive.
Hi, I'm Pam Neighbors. I'm the President and Chief Executive Officer for CareerSource Central Florida. Our mission is to make talent the best for business and to connect Central Florida residents to good-paying careers. We fulfill our mission by focusing on the skills of individual residents and aligning them to the growing careers that are in Central Florida. In the past year, we have served over 43,000 individuals by providing them career services, which include resume review, employment assistance, job referral, and training scholarships. For businesses, we have served over 3,500 organizations by providing them screened candidates and also providing them opportunities to train individuals on the job. CareerSource Central Florida is very proud to be part of this innovative and growing community in the Orlando region. I invite you to connect with us and learn about all of the services that we have for both residents and businesses in the Central Florida community.
In any business, you ride the line between numbers and people. It takes balance. CLA, CPAs, consultants, and wealth advisors will get you there.
I've learned a lot. Overall, yeah, I am happy. I think it was a good decision.
If you are very good at being a self-promoter and really passionate about what you're doing, the sky's the limit.
Full Sail University is where the next generation of creators are learning to build the future. It's where artists and creative thinkers unite with technologists and engineers. It's where you will get hands-on experience developing entertainment media and emerging technologies. If you have big ideas and even bigger dreams, start right here.
We all need someone to rely on whose mission is simple: to get him home safe, to sustain healthy communities, to help her reach the stars. When you need someone to rely on, it's Intuitive.
Hi, I'm Pam Neighbors. I'm the President and Chief Executive Officer for CareerSource Central Florida. Our mission is to make talent the best for business and to connect Central Florida residents to good-paying careers. We fulfill our mission by focusing on the skills of individual residents and aligning them to the growing careers that are in Central Florida. In the past year, we have served over 43,000 individuals by providing them career services, which include resume review, employment assistance, job referral, and training scholarships. For businesses, we have served over 3,500 organizations by providing them screened candidates and also providing them opportunities to train individuals on the job. CareerSource Central Florida is very proud to be part of this innovative and growing community in the Orlando region. I invite you to connect with us and learn about all of the services that we have for both residents and businesses in the Central Florida community.
In any business, you ride the line between numbers and people. It takes balance. CLA, CPAs, consultants, and wealth advisors will get you there.
I've learned a lot. Overall, yeah, I am happy. I think it was a good decision.
If you are very good at being a self-promoter and really passionate about what you're doing, the sky's the limit.
Full Sail University is where the next generation of creators are learning to build the future. It's where artists and creative thinkers unite with technologists and engineers. It's where you will get hands-on experience developing entertainment media and emerging technologies. If you have big ideas and even bigger dreams, start right here.
We all need someone to rely on, whose mission is simple: to get him home safe, to sustain healthy communities, to help her reach the stars. When you need someone to rely on, it's Intuitive.
Hi, I'm Pam Neighbors. I'm the President and Chief Executive Officer for CareerSource Central Florida. Our mission is to make talent the best for business and to connect Central Florida residents to good-paying careers. We fulfill our mission by focusing on the skills of individual residents and aligning them to the growing careers that are in Central Florida. In the past year, we have served over 43,000 individuals by providing them career services, which include resume review, employment assistance, job referral, and training scholarships. For businesses, we have served over 3,500 organizations by providing them screened candidates and also providing them opportunities to train individuals on the job. CareerSource Central Florida is very proud to be part of this innovative and growing community in the Orlando region. I invite you to connect with us and learn about all of the services that we have for both residents and businesses in the Central Florida community.
In any business, you ride the line between numbers and people. It takes balance. CLA, CPAs, consultants, and wealth advisors will get you there.
I've learned a lot. Overall, yeah, I am happy. I think it was a good decision.
If you are very good at being a self-promoter and really passionate about what you're doing, the sky's the limit.
Full Sail University is where the next generation of creators are learning to build the future. It's where artists and creative thinkers unite with technologists and engineers. It's where you will get hands-on experience developing entertainment media and emerging technologies. If you have big ideas and even bigger dreams, start right here.
We all need someone to rely on whose mission is simple: to get him home safe, to sustain healthy communities, to help her reach the stars. When you need someone to rely on, it's Intuitive.
Hi, I'm Pam Neighbors. I'm the President and Chief Executive Officer for CareerSource Central Florida. Our mission is to make talent the best for business and to connect Central Florida residents to good-paying careers. We fulfill our mission by focusing on the skills of individual residents and aligning them to the growing careers that are in Central Florida. In the past year, we have served over 43,000 individuals by providing them career services, which include resume review, employment assistance, job referral, and training scholarships. For businesses, we have served over 3,500 organizations by providing them screened candidates and also providing them opportunities to train individuals on the job. CareerSource Central Florida is very proud to be part of this innovative and growing community in the Orlando region. I invite you to connect with us and learn about all of the services that we have for both residents and businesses in the Central Florida community.
In any business, you ride the line between numbers and people. It takes balance. CLA, CPAs, consultants, and wealth advisors will get you there.
I've learned a lot. Overall, yeah, I am happy. I think it was a good decision.
If you are very good at being a self-promoter and really passionate about what you're doing, the sky's the limit.
Full Sail University is where the next generation of creators are learning to build the future. It's where artists and creative thinkers unite with technologists and engineers. It's where you will get hands-on experience developing entertainment media and emerging technologies. If you have big ideas and even bigger dreams, start right here.
Yes. Ladies and gentlemen, please begin to take your seats. Our program will begin in 2 minutes. Correct. Ladies and gentlemen, please begin to take your seats. Our program is about to begin. Ladies and gentlemen, please welcome back to the stage, Beverly C.
Okay, welcome back, everyone. I hope you all enjoyed that fabulous lunch that our Hyatt friends provided us, and I also hope you had time to visit with our exhibitors. So our first afternoon keynote is Bradley Friel. Brad is the Senior VP of Multimodal Planning and Environment for the Greater Orlando Aviation Authority. And in his role, he oversees all planning and environmental activities for the Orlando International Airport and the Orlando Executive Airport. And you guessed it, with the support from Brad and his team, this Airport of the Future Summit came to life this year. Please welcome Brad Friel.
Thank you, Beverly, and good afternoon to all you in the audience. Good afternoon. Thank you. You know, I got the lucky draw here, and I got everyone right after lunch. So I'll be talking a little airport stuff with you, so hopefully it'll get your mind engaged and start creating some thought for you all as we move through this presentation. And I really do appreciate the opportunity. I'm really excited to be able to share with you the Airport of the Future, where we're going as an aviation authority. But first, kind of start a little bit with who we are. We're the Greater Orlando Aviation Authority. We're controlled or governed by a 7-person board, 2 of which are sitting mayors, Mayor Dyer and Mayor Dimmings, and then 5 members who are appointed by our governor. As far as the airport in general, or MCO, we're the busiest airport in Florida. I guess it depends on the month when you say this. We kind of go back and forth with Miami. We're kind of like the Kentucky Derby a little bit. And we're coming around the stretch, so to speak, and hopefully we'll nose them out at the end of the year. But right now we're about 52 million annual passengers that process through our 3 terminal facilities. By the end of the year, we see ourselves at about 55 million annual passengers, which is about a 10% growth. And so when you think of a facility that's processing 50 million passengers a year and you do 10% on top of that, the need for facilities is very great. And so we really try to use technology to kind of close that gap between the demand on our facilities and our ability to process passengers. According to FDOT, we're responsible for $41 billion in economic impact for the region. We have the world's largest rental car market. And we also have we're the 4th largest airport in the country by land mass. And so think of Dallas, Fort Worth, and Denver as being a little larger than us. And then ironically, Southwest Florida Airport down in Fort Myers. As far as technology, so who here has actually gotten to experience the new Terminal C as a passenger or just someone that's gotten a walk through? I apologize for the walks. We are working on that. It's definitely a priority of ours to alleviate that issue, but we're working through that. But what I want to talk to you all about today is really about some of the technologies and everything that we've built into this facility that you as a passenger will use, and you may not know that you're using it, and some of the technologies you will notice as a passenger when you're using it as you move through the airport. There it goes. So on our arrival and departure, when you process through or you arrive to the airport and you go to the ticket counter, whether to check a bag or get a boarding pass, all of our facilities in there are what we refer to as common use. And so everything's integrated in as a common use, and the whole entire facility is common use. What we mean by that is on any given day, Airline X can use a specific gate. 2 hours later, Airline Y can use that same gate. It's not assigned to specific airlines. And what that does, and that's from the ticket counter, the bag claim, all the way to the gate. And what that does for us as an airport operator is it allows us to be really flexible with our facilities and to be able to maximize the use of our gates and facilities so that we're meeting the demand that's coming at us. We also have, our TSA screening lanes in Terminal C are 100% fully automated. So essentially, once you've put your bags in the bin, so to speak, you no longer touch it. You don't have to push it through all the way to the screening machine, and you process through. You revest at the end, and then you're on your way. And then we also are implementing 100% biometric screening for the international passengers. And this is an important piece, which I'll touch on later in the presentation, the importance of the biometric screening. Something you may not use is our baggage handling system. No, that's not an Amazon warehouse picture. That's actually an image of our early bag storage. So here at MCO, we're different than most airports in the sense that we have a lot of our passengers arrive 4, 6, 8 hours before their flight. And primarily it's folks coming off of cruise ships, or you're checking out at Disney or the Universal properties early, and you're checking out at 11, your flight may not be until 6 p.m., and you arrive at the airport, and you're sitting there with your bags. You see it in our terminal today when you walk it. You'll see large families with tons of bags, and they're just waiting. Down in the South, because of this, we can process you in 6 hours earlier. You divest yourself of your bag. It goes into this early storage system, and everything's tagged with an RFID on a tote. And essentially what it does is it allows, so once you've come in and now your flight is now within that 2-hour window, the baggage re-interject into the system, and then it makes its way to the aircraft. And so it's been an important feature for us as far as being able to help those passengers. It's just kind of a quick video. This is our, so to speak, one of our Disney rides. You cannot ride the totes. You'll get injured if you do. But the real takeaway on this is, if you notice, you don't see people. And so it's very minimal staff that's really required, and they're all back behind the screen monitoring the entire system as your bag moves through the system. Another element we've implemented in is a digital wayfinding system, which is nothing necessarily revolutionary, but in the way that we're working at using it and the way that we're intending on using it in the future as technology develops, is to be able to, back with that common use environment. So if I'm got an airline that's at a particular gate, JetBlue, for example, and then 2 hours later I want to put Breeze Airlines on it, I can't have someone going out there with a ladder and changing the sign out. I need to be able to do this dynamically on the fly. And so the digital wayfinding really helps facilitate that. But as we move forward in the future using LiDAR and other technologies where you can actually map the passenger's flow throughout the terminal, you can see how they're using the wayfinding, and we can use that data to improve our wayfinding on the fly, as well as you can also start to notice where people stop and start, the decision points. And so you can say, hey, I may need some more signage or wayfinding there to help their journey. And then you can also use it even with our concessionaires and others, where we can use that data, mapping the flow of the data through this system to tell or to be able to identify certain concession areas that have higher traffic volumes than others, which would then make that more valuable real estate, so to speak. Experiential media, so we've talked about kind of the processing of passengers and improving the efficiency of our flows, and experiential media is really, it's public art, but it's really about an opportunity to introduce technology and to be able to tell the story of the Central Florida region to the 50 million people that come through here. So using this experiential media, which has got, it's CGI and there's a bunch of other fancy technology that's behind it, that allows you, here's a quick video that kind of shows you, folks interacting with the experiential media piece. I always like the one with the fish following you. But essentially what this is about, it's about telling the story of Central Florida through digital media, and that's really what we're trying to accomplish there, and highlighting some of the areas. And it's really about, kind of goes into, Visit Orlando and others where it's, you don't know the half of it. We've probably heard that in Orlando. It's about telling the story about who we are as a community. So we're using this technology to really highlight that story in our terminal. I mentioned the biometrics piece earlier. Here's just an example. Right now, it's really implemented in with our international passenger processing in Terminal C. We're actually implementing in other areas of the building. It's biometric data, and as soon as the data's been used, it's dumped and it's deleted. So we don't store the data in any server or anything like that. But this piece becomes important as we move forward into trying to create the touchless environment. So coming out of post-COVID, as an airport operator, one of the things we learned is obviously, safety is paramount, and being able to create a touchless environment where, as a passenger, you don't have to pull out your boarding pass or pull out your ID and hand it to someone. And so we got all this touch point going on. We're trying to minimize that so the process through the entire facility is seamless for the passenger. Digital twin. So I put this image on here for a reason, the one on the right. It's because about 5 years ago when I first heard the concept digital twin, I thought maybe it was like a fertility technology or something like that. I'm a planner, so I'm not very bright. But as I've been more immersed in it, I've come to learn one truth about it, which is a truth that in the airport world, we say if you've seen one airport, you've seen one airport. And so what I'm learning in the digital twin world, you've seen one digital twin, you've seen one digital twin. Everything's different, and it's really up to your interpretation. What, in my mind, what is a digital twin? But we've introduced this, and we're relying on this in quite a few systems in our airport, particularly in Terminal C, from queue management, virtual docking. You see the list. As we go through, and it's something that we're very mindful of every time we do a project, is to create that digital twin, so that as we continue to build out the facilities and you marry all this together, then you really start getting that power that you can really drive from being able to have the digital twin of your facilities. As an example, our queue management systems that we use, it's, when you come up, you see the sign that says it's a 27-minute wait or a 10-minute wait. We're tracking everyone through using LiDAR. We also use Bluetooth. And we track everyone that moves through those security checkpoints. And this is something that eventually we'll be able to push through the entire terminal facilities. Like I said earlier, using our dynamic wayfinding is to track, not Big Brother track, but just to track. So even from a facilities management, from our renewal and replacement program, to be able to tell where the high traffic areas, the high wear areas of carpets are, or tile, or bathroom usage. Hey, this bathroom's being heavily used. We need to be increase or get janitorial out there now because there's probably the need, the tissue needs to be replaced and so forth. But on the queue management system, we go through and we analyze, and this is just kind of a little screenshot. I think it's a video. I passed it, sorry. But it's basically, it tracks each passenger as they move through our checkpoints. And so that's what we're using to be able to predict what your checkpoint time is, as well as identify where bottlenecks are, high use areas are, so that we can improve those flows. As it's kind of like a learning, we're always learning how to improve our systems and flow. On the visual docking side, and so as you're a passenger, you're arriving here at Orlando and MCO, and if any of you have ever arrived here in August at 4 o'clock in the afternoon, and you've been sitting on the plane for 4 hours and you just can't wait to get off, and then the next thing you know, the pilot comes in and says, sorry, we're on a ground stop because of a thunderstorm. And that's just because we can't have live humans out on the ramp during a thunderstorm. And so the visual docking guidance system is basically we've created a digital twin of each of our gate areas. And the twin is basically to be able to accommodate any size aircraft from a regional jet all the way up to the largest A380 jets that fly today. And so the system knows, we use a resource management system that pushes the data to this. And the system knows, okay, this is an A380 that's coming up. And it's basically what you're seeing is what the pilot sees on the side of the building. And so it just guides them straight in all the way up to the point to where he knows where to stop so that the passenger boarding bridges fit to the door, so to speak. And so, so no wing walkers. You don't have the guys with the flashlights anymore directing the aircraft in. So it's a great advancement for us, particularly in thunderstorm areas. We also use virtual ramp control in our terminal down there. So in the airline and the airport world, you know, there's air traffic controllers and then there's ground controllers. And the ground controllers are not FAA employees. They're actually typically employees of the airline. And so traditionally each airline would have their own ramp controller that would sit in a little tower, and you look around our airport, you'll see the little towers. And they're the ones that are telling the aircraft when to push back from the gate. And so for Terminal C, we've integrated into this virtual ramp control where now we've created a digital image, so to speak, of our airfield, of our ramp areas down there. And we essentially track the aircraft from the time that they arrive all the way to the time that they come to the ramp. And so the folks in this virtual center are the ones that are controlling all that, talking to the pilot, telling the pilot when he can approach the gate and then encounter the virtual docking system. I'm trying to advance it. It won't advance. Helps if I hit the right button. Sorry about that. This is just a simulation of what's going on. So you can see there's a Delta flight arriving over there on the right. He's going to arrive and he's going to taxi over to Airside 4. But essentially it's the color coding, you know, the blue is occupied, the orange is available. But essentially it's a system we use to track everything that's moving around on our airfield. We also have an app, just like everyone else. We're in the process of doing quite a bit of improvements to our app. Introducing the turn-by-turn navigation features. Here again, this is a wayfinding function so that folks that have the app on their system can say, hey, I'm going to gate 13, and it'll just tell you turn by turn. As we develop our twin, so to speak, of our facility, particularly the North Terminal, we'll get better and better at that with it and be able to produce, you know, kind of a 3D, so you'll be able to see yourself in 3D where you're at. Within the terminal facility. But on that app, we also, you know, we have a reservation system for security checkpoint. A lot of you may not know that. It's publicized, but it's not widely known, which is a system where you can say, hey, I know I'm flying Spirit Airlines at a certain time. You can get on the app a couple days early. You can make a reservation for a specific time to be at the security checkpoint, and there's a specific lane that you would go through. It works like Clear or TSA pre-check, so to speak. Dedicated lane, and you just arrive when you're supposed to, and you get right through the checkpoint. So it's a nice feature. We use we've twinned our airfield, and we use it, you know, for some of those other features I was talking about. But this is a really important piece. Is we use it on our operations and maintenance side for inspection and management. So on various times throughout the day, our airfield operations folks, they'll do visual inspections of all of our runways and taxiways to make sure there's no foreign objects, debris, or anything that would create a safety issue. And so, you know, as they go through and do their inspections, they'll note stuff, or if they, for example, if they're out doing their inspections and they see a flock of barn swallows, which birds and airplanes don't mix, if they see a flock of barn swallows, they can note that on their inspection report, which then automatically pushes it to our airfield ops folks to say, hey, there's some birds out here. I may need to go out and check and see if I need to take some mitigative actions to be able to get them to move on and to not be an interference with our operation. So there's a lot of elements to this. We use this the first time. So airports annually go through what we call a Part 139 inspection, which is our certification with the FAA. And we use this very heavily, you know, leading up to that, which really helped us from the maintenance and the safety aspect of our airfield, really hone in on problem areas, get them fixed right away. And we had one of the best inspections in the FAA history as far as our airfield is concerned, and a lot of it's attributed to this because of this real-time data that we could push out to our operations folks. Here again, and it all boils up or rolls up under this resource management system, which basically keeps track of all the airline activity, the flight schedules and everything. So the virtual ramp system knows what size aircraft is coming in through this system, which controls the whole thing. We use it for economic development as well. We work very closely with Enterprise Florida, the Orlando Economic Partnership, on opportunities to bring development to the Central Florida region, and we created this site, which is a GIS website, essentially. But essentially what we've done is much like the property appraisers' websites, where they have, you know, an inventory. It's like you look up your parcel if you own a piece of land. Hey, my property's zoned R2. I've got a 2,100 square foot house on it. Well, this goes further. I've got all my environmental data, all my permitting data, and we're just keep building on this. And it's a database so that we know everything that's known about a piece of dirt on this property will be flowing through this system. So it's just a way here again for us to get a better handle on 12,000 acres almost that we have as an airport. Looking forward beyond, so we've done a lot of technology into our system, and where are we going from there? So we're going to continue to integrate what we have into these systems, and as we continue to go through and expand our facilities, we're building into all our construction documents. You know, it used to be a time when this, I'm going to date myself, but you know, when you did a construction project and you got what we refer to as the as-built, you know, after it's constructed and here's what they actually built, it would come on, you know, it would come in a big plot, you know, vellum roll. And, you know, you'd store it and stuff like that. You pull it out and you flip the pages to figure out what it is. And then we said, okay, well, now we're going to require you to deliver it in CAD or a PDF file. And so now as we, you know, now we're into BIM and then into the digital twin is where we're heading with that as we go through. And so as we do that, and of course it'll take time. This is a crawl, walk, run kind of process for us. But, you know, we've got millions of square feet of facilities. And so as we build out our facilities or renovate our facilities, we're going to be creating the twin of our facility. I mentioned earlier the single token authentication or the biometric screening piece. So this kind of goes back to that touchless environment that I'm speaking of. And so where we're heading, and this is, you know, it'll be an optional program for domestic and, you know, domestic passengers as well. But basically you come, you check into the airport, basically they know you through biometrics, who you are, what your flight is, and all your pertinent information. And so as you navigate through our facilities to board your aircraft, essentially you don't have to do anything. You don't need to pull out a boarding pass, you don't need to pull out your ID. You just seamlessly move through TSA, you approach TSA, scans your face, it knows who you are, it knows what flight you're supposed to be on, and you just move on all the way through to the gate. And so this is it's important. As I mentioned earlier, coming out of COVID, this is one of those things, the lessons learned. And so this is an important way of creating a touchless environment through the airport for the benefit of all, actually. And then, you know, as we continue to look forward beyond just the processing of passengers and being more efficient and being more safe for the traveling public, is from an authority standpoint, we're looking, you know, we're always looking out where we can embrace the digital twin and the simulation. And, you know, there's obviously a strong presence of that here in our community. And so the question is how can we leverage it? And one of the ways is as we, in the aviation industry, we're looking at a paradigm shift of what's occurring for us. And there's the advancement, or there's the Advanced Air Mobility, or AAM, which goes by a lot of other acronyms that you may have heard: VTOL, vertical takeoff and landing, autonomous drones. All these technologies require use of airspace, which is, in large urban areas such as ours, very complicated. And so The FAA has been working on this with they've just recently came out weeks ago or just a few weeks with a concept of operations on how all this is going to work. And one of the things they highlighted in that is the need for advancements in air traffic management, including the creation of corridors, highways in the sky, so to speak. So I always visualize it as, you know, if you've seen Back to the Future 2, the very beginning of that movie, Marty and his girlfriend get in the car with Doc Brown, and Doc, you need more road. Well, where we're going, we don't need roads. And then the next scene, it shows them, you know, 25 years in the future, and he's flying his car, and there's road signs and all kinds of other stuff floating in the sky. Well, that's kind of what's going to be needed in order for advanced air mobility to actually work. And the application of advanced air mobility, you know, in its initial concept is, you know, it started with drones, right? And then autonomous drones. And then where advanced air mobility is now is, you know, there's many manufacturers, OEMs, that are in the market that are trying to get their aircraft certified. And they'll be certified around 2025, 26 timeframe. So when we expect these aircraft to be certified for flight, initially they'll be piloted, and they're looking at, it's Uber kind of concept, where you can get in with, you know, 4 or 5 of your friends. There's a pilot. The vehicle takes off, takes you to where you want to go, whether it be Disney, downtown UCF, lands right there, and then keeps on going. But here again, it's all using that airspace. And so the challenge for the aviation industry is figuring out that dynamic, right? And so where we see Orlando and MCO in particular as being involved in that area is leveraging the assets that are in this room and in this state and bringing us all together to help problem solve this. The FAA, like I said, they have a concept of operation. There are some testing sites that they're doing very minimal testing for this, but you need to physically create the corridors. You need to physically create all the sensors and everything that's going to be required for all this to come together and work together as a unified system. And so I think as we move forward, being able to you know, leverage what we have and create, whether it's incubator labs or other types of arrangements, to where we can jointly all work and problem solve these issues together. And you know, the first piece is you know, kind of establishing of a corridor where we can do some of this testing. There's one up in Syracuse that was really built off of some testing that the military was doing with Reaper drones. But now, so UPS and Amazon and all they're up there testing their autonomous drones, trying to figure out how am I going to deliver packages to your house, right? I mean, we all heard that's coming. The reason why it's not coming yet is because they haven't figured out the airspace. And so that's our big dilemma, I think, moving forward in the industry. And if we can solve that problem collectively, then it'll all be here sooner, and we'll be able to, you know, take Brightline from Miami to Orlando and then hop on an advanced air mobility vehicle and go to Disney or go to the Port Canaveral or wherever you need to go. So what it is really it's that true multimodalism that we're looking for. And we're going to embrace advanced air mobility. We just need to figure out how to make it work. So hopefully we can partner together on that. And that's really kind of my presentation in a nutshell. I don't know, maybe a little time. I don't know if you've been doing questions or how that's been working, but if there are any, I'll be happy to take them. If we're not afforded the time here, I'll be off to the sideline, and I'll be happy to interact with any of you. So thank you all for your time.
Thank you, Brad, for that impressive presentation about the airport of the future. As we listen to Brad talk about the challenges going forward, I would offer to you, Brad, probably in this room collectively, we may have 99% of the expertise you need. with that, we're going to now transition to the highlight of the day as far as seeing what's new at this facility out here, the Brightline Tour. It is going to be my pleasure to introduce Christine Kefauver, the Senior Vice President of Corporate Development for Brightline. But before that, we have an introductory video on Brightline.
Everybody dreams, but few dream of amazing, impossible things. Not for themselves, but for a greater good. These are the dreams of pioneers. The truly brave. The ones bold enough to take the very first step and then face what it seems like a never-ending obstacle course of naysayers, eye rollers, and door slammers. They spent years moving mountains so that the rest of the world can move forward. Until that one day, that one moment, the dream becomes a reality. This is our dream, to change the way people move. This is our time. This is the moment. Let's swing for the fences. Let's reimagine the ride together. Go Brightline.
Everyone needs a little Aerosmith walk-on song, don't you think? Good afternoon. And so as Brad mentioned, being the presenter after lunch, I'm the last one between your happy hour, your tour, whatever it is. So thank you for remaining here today. I'm Christine Kefauver with Brightline Trains, and I'm excited to tell you a lot about what we're doing. And as I listened to some of the presenters earlier, I have a confession. I haven't seen The Matrix. I haven't seen Iron Man nor Tron. Yes, I've seen Back to the Future, so I got you, Brad. So I'm not going to bring to you a whole bunch of new technology and so forth, but I'm going to talk to you about how we're using innovation and technology to deliver a world-class transportation system right here in Florida, and looking forward to connecting here in our backyard very soon. So think about that. That video, it talked about the world needs more dreamers and doers. But above all, the world needs more dreamers who do. And if I think about this audience, that is exactly what I think about you are doing every single day. So thank you for what you do in the state of Florida, but also in the state of innovation and technology. So what is Brightline? We are privately owned and operated. We are an intercity passenger rail system. We look to connect city pairs that are too far to drive, but too close to fly. And even if you choose to fly, sometimes the convenience of that, no offense, Brad. Oh, good, he's left there. Oh, no, there he is back there. But like we all know what happens in the afternoons with the rainstorms and so forth. So Brightline is looking to connect the state with intercity passenger rail. And the founders of our companies, and we really started about 15 years ago, and it's been 10 years to get us here to Orlando, so we're so excited to be on the cusp of it. But we really do want to change the way that people look at travel in America.
Many of you have been to Europe or Asia and you've taken high-speed intercity passenger rail trains, bullet trains, whatever. It's kind of hitting the easy button, isn't it? It's knowing where you want to go, and once you enter the station even, you have an experience that you're ready to go. So we really do look forward to change the way that people view travel in America, and we're starting right here in Florida. So with that, but Florida's not the only project we're working on. There we go. So we looked at city pairs that are too far to drive, too close to fly, right? And so Florida became the hotbed. You know, I often go back to, way back Michigan, 1991, I was working for Federal Highway Administration, and that Intermodal Surface Transportation Efficiency Act of 1991. Let that roll off your tongue, right? But it's the Transportation Reauthorization Bill. In 1991, there were 5 high-speed rail projects listed. Tampa to Orlando was one of those 5. So we're still working on that today, and that's our commitment, is to get us to Tampa ultimately. So we're currently operational in South Florida from Miami up to West Palm Beach. So that's our initial operating segment. We have been busily working on expansion and connecting to Orlando. So we'll talk about our percent complete with that. And the goal is to take us to Tampa. At the same time, we have a sister project out west called Brightline West. And that one is a fully dedicated brand new rail line that is connecting Las Vegas to the LA area, 218 miles. In Florida, we know from South Florida to Orlando, there are about 30 million trips a year taken. 1% is done by aviation. The rest is done by car. Not very productive as far as I'm concerned. In California, we're looking at there's probably 50 million one-way pairs connecting those cities. Our goal is to have that system opened and operational in time for the Olympics in LA. So we're excited about moving that project forward as well. But the rest of today's conversation will be on connecting in Florida. So think about it. In 2024, Visit Orlando is estimating that about 80 million visitors will be coming to Orlando. Roll that back to the 22.25 million residents that we currently have living here. We only have a certain amount of capacity in our roadway network, and quite frankly, there are generations of folks that don't want to own a vehicle, nor are they interested in driving everywhere they go. I mentioned we're operational in South Florida. We opened operations in 2018, closed during COVID, reopened a year and a half or so ago, month over month. The month of March this year was 70% better than March of last year. So, think about your business model. If you could have that type of growth, I mean, you wouldn't be sitting here. You'd be out doing something else, right? Because you got to, cook the bacon type of stuff. But what we're really excited about is our ridership. We are running at full trains. We've already ordered new train sets. To add to that, we can grow up to 10 train sets. Here's a picture that you're looking at. That is the Intermodal Center. Brad and his team at the airport 2 decades ago said, we want to be the intermodal hub for the region. And although you see Brightline in the station there, that if those of you who are joining us on the link, you will take the terminal link. So there's one mode of transportation connecting at the intermodal facility. Brightline is coming in next. We've built out our station. That's what we'll be touring. But there's also room for commuter rail, Sunrail to expand. I know that's been both Mayor Dyer and Mayor Deming's highest priorities, is getting Sunrail connected to the airport, which makes sense for both a tourist as well as a journey to work type trip for folks. I live in College Park. I'd love to get on the Sunrail train, come into the airport, and take Brightline on to whatever my final destination is. That is the ecosystem that we've all worked really hard to begin to develop. So we've had lots of folks busy during COVID building this 170-mile extension from West Palm Beach to Orlando International Airport. And as I mentioned, our ridership is just booming. Just last weekend, we had our first, third, and fifth busiest days just this past weekend in South Florida. We tie into activities that are going on and look for ways to help get people to where they want to go. So the first question we often get, well, how long is it going to take? How much is it going to cost? When are you going to start operations, right? So I can give you two of those three answers right now. When we opened up our station at the end of April, there's a picture of it, there's the unveiling. Some of you were able to join us for that. We announced that we were going to have tickets starting at $79 one way to Miami. We have two classes of service. They're called Smart and Premium. So you can equate that to business class and first class. We really look at all of our guests of having a phenomenal experience whenever, from the time you open up your app, goberlang.com, and book your trip, which you'll be able to do, to the time that you are arriving at the station and your Uber trip is meeting you there with geofencing, geocoding that they'll know when you're arriving and pick you up and take you to your final destination. We've worked through all of that technology in the background. So $79 is the starting price to get to Miami, $149 in our premium, which includes beverages and food in the station, on the train, so really high-end experience as part of that. We are a tenant of the airport. We have not built the facility itself. We got the shell of the station and we've built that out. So anybody joining us on the tour, you'll be able to experience that. Almost 40,000 square feet of that. So for those who can't join or want to look at the technology that we have used, this next video to the ultimate station that is there. So here's your next video. So that's generally what the station looks like here in Orlando, which we're so excited about as well. We talked about it being the price point to get to Orlando. If you take our express train to Miami, it'll be 2 hours and 59 minutes. If you want to stop in other station locations, say your destination is Aventura, that all the way to Miami would be about 3.5 hours for travel. But think about your guest experience. Once you walk into our station, you have Wi-Fi. So you're productive from the second you walk into our station to the time you leave the station, wherever your ultimate destination is. From a technology standpoint, excuse me, earlier this week we did announce our partnership with Starlink, with SpaceX, to provide seamless Wi-Fi and connectivity all the way through. And the way I like to say, you can be as productive or unproductive as you would like on our train. So say you're going down to Miami for a 9 a.m. meeting, you hop our train, you arrive to Miami likely before many other people do at the office in Miami. You have your meetings, you're really productive, you spent the time on your train preparing for that, you have a client lunch, and then you turn around and you're back on the train and you're back here in Orlando at the airport by 4 o'clock in the afternoon. I dare that you would have that level of experience if you ever chose to drive that experience. So we are real excited about opening to Orlando. Like I mentioned earlier, we're about 92% complete on the construction. We look to be complete by next month, end of next month, here very soon. But then we do have a testing system. Brad talked a lot about the partnership with the FAA that the airport has. Our partnership was with the Federal Railroad Administration. There are parts of our system, we go 125 miles an hour along the beach line and our own corridor, of course. And then we also go 110 miles an hour in South Florida and are in the middle part of the state, and then 79 miles an hour in South Florida. So the Federal Railroad Administration, of course, wants to make sure safety first, everything works, all the signals work, think about how we do all the crossings with local roads. So we've been testing along the way, hit some history marks here in the state of Florida with that, but we're really proud of the level of service and the quality of service that we're going to provide. So I was able to take one of the test trains, and it actually went 130 miles an hour because you have to test 5 miles over. About a month ago, and it was fabulous. So because we can't take the train quite yet from Orlando, here's a video for you to get a feel of what that looks like. So we will have 10 train sets that are going to be operating hourly service from Miami up to Orlando. And they need to get repaired every single day, right? Just like your vehicle, we do, our heavy maintenance is going to be right here about a mile south of the airport, and we call that base camp. That's the highest tech type facility. Literally, you can eat off the floors. Here's a few pictures of them. But we also knew as we were preparing for this that this is a whole new job set and skill set that people would need to have to maintain these vehicles. They're Siemens owned. They're owned by Brightline, but assembled for us by Siemens. They're state-of-the-art, and they're ready to go. So we built the system, this maintenance facility, to accommodate the heavy maintenance of all of our trains. So 7 trains will sleep here every night, and a train wash as well that is fully automated using 80% recycled water and rainwater, et cetera. But we knew that we had to build out a workforce to help us with that. So about 2 years ago, I was making a presentation to City Council at the City of Orlando, and it was suggested by Mayor Dyer that we reach out to Valencia College and partner with them. So we did. We immediately reached out, and I saw that they were a sponsor today. Shout out to you all. They immediately responded with, how can we help? How can we build out a program on machinery and electronics that meets the needs of Brightline? Once again, high skill, high wage jobs. Our starting jobs start at $20 an hour. And so that partnership's been great. And I have another video for you that you can see what that looks like.
With the launch of the Brightline train in our area coming soon, there was going to be a need for technicians.
We knew that we were going to need a specific type of skill set and education in order to maintain the trains, the facilities, the track, operate our system once we get up to Orlando.
Valencia College is a part of providing the skilled workforce that Brightline and Siemens need.
Everything in the program just fit better with me, and I knew that if I could really take on a challenge, it would be worth it in the end. I came here, I thought it was just going to be a tour. The facility was not like any sort of job site I've been on before. Definitely made myself proud doing this. It's nice to tell my family I got myself together, I got myself on my feet.
This is not just a well-paying job with benefits, it is actually a career. It's something that's a path for progression that's going to take them through the rest of their lives.
I've had the chance to meet Davon a couple times. He grew up in West Palm Beach. He grew up seeing Brightline around, and it's so funny that things would come full circle for him, and he's just so excited to be part of the team, and we're happy to have him. So we get to Orlando. Once again, we will open up operations later this year. We do not have that exact date for you yet because we need to go through that FRA certification process, and we have no control of that. They've been working with us every step of the way. They know as soon as we get operational, it's great for them as well, because they're looking to figure out how do we bring intercity passenger rail like this to the rest of the country. I'd say we're a little bit behind. So now phase 3, and that's getting from Orlando to Tampa. You may have heard some stuff in the news. We're working really closely with local stakeholders to find the best alignment and moving that forward. We have already identified a station location in Tampa. We're working with folks there. We do follow, once again, a federal process. It's called NEPA, the environmental process, where we look at any impacts from noise, vibration, et cetera, on the alignment, and most of this will be within the I-4 corridor once we get through the tourism type area. And in that area, we're going to hit speeds up to 150 miles an hour to get us to Tampa due to the direct connection. So the Florida Department of Transportation submitted this project to the Federal Railroad Administration a couple months ago for their Corridor ID program, and we're getting ready to be set to go to help get funding for this leg, 83 miles in the next federal cycle for some grants for intercity passenger rail, and that's February of next year. So we're excited about being ready for that. We've heard a lot about partnerships today. This is what that alignment looks like. So coming out of the airport, connecting the convention center, and then near the Disney area. And where you see that cross-hatched, that is where Brightline can design and construct to be ready for when the community wants to expand Sunrail, commuter rail east-west. They can drop it right into our track system, and we could work together in partnership to make that happen. So we're excited about that opportunity. We see ourselves as an ecosystem, and that east-west mobility with commuter rail really helps all of us in solving for some of our transportation opportunities. With that, that completes my formal presentation. I encourage you to click the QR code, learn more, go to gobrightline.com. We will have a tour of the station once this wraps up. I think George will give you directions on how to get there. I've got some teammates will do tours of the station. I do have an apology to make. We could not have one of our trains in the station because they're all being used right now on part of that testing so that we can hurry up and get to operations. So I hope you can appreciate that. I'll be around. I'll be part of the tour as well. If you have questions, I'll be happy to answer those at that time. Thank you so much for inviting Brightline to be part of this conversation. I may not be the highest tech person, but I look for Brightline to help connect and be your mobility of choice as you're working with others to connect the high-tech Florida all together. So thank you so much and have a great afternoon.
Thank you, Christine. I don't know about the rest of you, but I think we'll be on our way to Miami as soon as they get this cranked up. I'm going to wrap things up here and then give you some instructions on the tour over to Brightline. First, I want to thank some people. Our conference chair, Beverly C., she's been a great partner in all 8 summits. She's been the only chair we've ever had, and we really thank her for all of her efforts. I would also like to thank our NCS Chief Operating Officer, Neil Finkelstein, and from Orange County, Simone Babb and her team. They've been wonderful in helping to plan this event for you. Finally, I want to thank the speakers and panelists. When we talked about pulling together this group of people to talk about digital twin technology and the future of digitalization, we really wanted to get a good, solid group of people. And believe me, when I tell you from people I've talked to, these are as good as it gets. A big hand for our speakers. And finally, the role of the National Center for Simulation is to grow the modeling and simulation industry, and that sounds very simple. We are fortunate to have the Defense Department here in Orlando with their huge business and $7 billion in contracts that go out every year, but that's just the base. We, as part of our mission, were brought on board to help integrate that technology with other vertical markets and other industries. And as we have heard today, if you look at the rate of spending for research between the Department of Defense or the government in general versus private industry, in the 1970s, the government was funding everything. That model is flipped around now. So our role is to help integrate all of you together, to work together with academia and government to help grow our technology, grow our job base, and have some really neat experiences in the future. So with that, I am going to transition now to getting you guys directions for the trip to the Brightline facility. What I will ask is that when we leave here, exit out the back doors, you will see tour guides holding signs, much like you see in the theme parks, and they'll say Brightline on them. Divide up as equally as possible. I think they're trying to get groups of about 20. And they're going to escort you over to the tram that'll take you to Terminal C, and then we'll go from there. If you have any questions after Christine's presentation, feel free to ask any of the tour guides. They will have, Christine assures me they will have the answers for you. So anyway, once again, thanks to everybody. Thanks to our host at the Hyatt. You did a great job, and we'll look forward to seeing you next year.